In episode 29 of the SOC Level 2 pathway, we're going to go through the details of the Caldera framework, the Caldera tool, which is all part of the threat emulation module of the SOC Level 2 pathway of TryHackMe. And Caldera is essentially the alternative to Atomic Red Team and Atomic Test that we ran in the last video. So it's literally the last video, the one right before this one on the SOC Level 2 playlist. We went through this tool called Atomic Red Team by Red Canary, which is a really powerful framework for doing threat emulation, detection engineering, and essentially running tests against your given system using the MITRE ATT&CK frameworks, adversary techniques and tactics, etc. So very, very useful tool, very powerful tool, and Caldera is just another alternative to the Atomic Red Team tool, which allows you to do very similar activities for threat emulation and detection engineering and threat modeling, etc. So the introduction is as always, and then we have the overview of Caldera, running operations with Caldera, in, through, out, emulation to detection, autonomous incident response, and then of course we have a case study, which means we are going to be emulating the advanced persistent threat group number 41, and then we're going to go through the conclusion. I'm going to give you a review of some final notes, and then you will be dismissed for today. So that is what we got for the overview of the Caldera video, the Caldera room. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers, the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the Caldera video. So far in the threat emulation module, we have learned and understood, discussed the concept of threat emulation, threat modeling, and we've even used a few tools to pull it off, one of them being Atomic Red Team. Now, Caldera is going to be an alternative to the Atomic Red Team tool, so I'm very interested to see how it's going to run. Obviously, I have never gone through this exercise before, so this should be a pretty interesting concept and room for us to experience together at the same time. So if you don't already have access to TryHackMe, then I would recommend that you get it, because it does provide a controlled environment for you to use these tools and do threat emulation techniques without actually damaging your own computer or anything like that. So in my opinion, it's a very convenient and functional, effective way for you to run as many different ethical hacking, pen testing, threat engineering type exercises all in one platform, because they also provide the target machines to you. They provide the attack boxes to you, meaning the attacking machine, but you can always just download Caldera on your own machine and use one of your other computers, for example, as the computer that would end up being scanned, or using it as your sandbox type of an environment. You can use VirtualBox and download an ISO image of a Linux machine and use that as your target machine. So there are a few different ways that you can do it without getting the membership to Caldera, or excuse me, the membership to TryHackMe. But my recommendation is usually to get the TryHackMe membership. So what we're going to be focusing on today are these objectives: the breakdown of Caldera's core terminologies and functionalities, the application of planning and grouping of adversarial use cases, automation of incident response via Caldera, it sounds like a very powerful concept, and then the implications of threat emulation to detection engineering. Of course, we're going to be using this overall concept of the tactics, techniques, and procedures, and how significant it is to actually use that for threat engineering and detection engineering, etc. So it's a very, very powerful concept, and this is something that we've done a lot, this module, this concept of the TTPs, and using the MITRE ATT&CK framework to actually track down the TTPs and use them inside of our exercises. So this is going to be another one of those concepts that I feel like we're going to be talking about repetitively for a very, very long time as we go further into cybersecurity. The prerequisites of this room would be the introduction to threat emulation, Atomic Red Team, Windows event logs, and of course Aurora. And all of these things exist on this channel already. These two were inside of the threat emulation module. So it's actually the last series of videos. Atomic Red Team is literally episode 28. So the episode right before this one in SOC level 2 playlist is going to be Atomic Red Team. And then Intro to Threat Emulation, I think, is like a couple of videos prior to this one. So it's still one of the recent videos inside SOC level 2 playlist. Windows Event Logs, we've done several videos on that. And I've done a couple of videos on Aurora, which is just an application that is used with Sigma rules, excuse me. It uses Sigma rules to detect potential indications of compromise or actual compromise attempts. And it's a very powerful tool. So we'll be using that. And you can use it inside of the event viewer, typically, if it's already been launched. And I will go through all of that. So I'm kind of getting ahead of myself. But these are our prerequisites that we have for this particular video and for this episode that we're going to be going through. This is actually a hard level room from TryHackMe. So I'm really interested to see how difficult it might be. And they say that you need 120 minutes to pull this off, which usually means that it's actually going to be a pretty crazy room. Because usually the ones that are like 60 minutes or 90 minutes, it takes me like 2 to 3 hours to do the full recording because I have to go through the read through of all of the contents of the room and then go ahead and run all of the practical exercises. So I'm really curious to see how long this is actually going to take. Right now it is 1:49 p.m. as I start this recording. So this should be quite an interesting experience for us to go through. Obviously, you're going to see the edited version of this video, which means I'm going to cut out a lot of the research time and all of those things just so you can actually get the meat of the content. But apart from that, I think that should still end up being like 2.5, 3 hours of video. So we will see how this whole thing goes. Refer to the timestamps if you want to jump to a specific section to answer a given question that you're most interested in. Everything I do is actually timestamped, and it's broken down by the actual names of the tasks themselves right here. So all of that being said, let's now talk about what Caldera actually is. Caldera is an open source framework very similar to Atomic Red Team, and it's designed for autonomous adversary emulation exercises. It enables the user to emulate real-world attack scenarios and assess the effectiveness of the security defenses. So this is very similar to what's going on with Atomic Red Team. And of course, it's built on the MITRE ATT&CK framework and the TTPs, or probably the IDs of the TTPs that are all listed on the MITRE ATT&CK framework. And again, there are multiple videos on MITRE ATT&CK, including the last one that we did on Atomic Red Team. So this is another one of those concepts that we've been talking about a lot lately on all of the recordings on this channel. The use cases of Caldera: you can have autonomous red team engagements. So the original Caldera use case, the main one, the framework is built to emulate known adversary profiles to see gaps across your organization's infrastructure. And this use case allows you to test your defenses and train your team on detecting threats. Manual red team engagements: so aside from automating the adversary profiles, you can actually customize your stuff inside of Caldera based on the red team engagement requirements, and it allows you to replace or extend the attack capabilities in case a custom set of TTPs are needed to be executed. An autonomous incident response: blue teamers can also use it to perform automated incident response actions through deployed agents, and this functionality aids in identifying TTPs that other security tools may not detect or prevent. So this is actually something that we did not cover at all with Atomic Red Team, because incident response is usually provided by Red Canary, which is the paid tool that's available through Red Canary. And Atomic Red Team is their open source framework for doing threat emulation, but there was no element of it that actually does automated incident response. So Caldera is actually very useful in this sense that you can do autonomous incident response, and we'll see just how deep that actually goes. The breakdown of this: so we can see that the information in this section is required to understand the framework better, meaning there are going to be the critical items that are used in Caldera. For example, agents. And agents, this is a universal term inside of cybersecurity when it comes down to endpoint detection. These are programs that continuously connect to the Caldera server to pull and execute instructions. And agents are typically installed on individual endpoints, so we'll see if that's actually the case here as well. Then there are the abilities, which are the TTP implementations which the agents execute. Then there are adversaries, a group of abilities that are attributed to a known threat group. Operations run abilities on agent groups, and plugins provide additional functionality over the core usage. These are going to be discussed in detail as we move forward. So agents, given the name, they are programs continuously connecting to the Caldera server to pull and exercise instructions. They communicate with the Caldera server via contact method initially defined during agent installation. It has several built-in programs, and this is the Sandcat, which is a Go language agent that can establish connections through various channels like HTTP, GitHub, GIST, or GIST, I guess we should say. And then we have DNS tunneling. Then there's Manx, which is another Golang agent that connects via TCP and functions as a reverse shell. And then there's Ragdoll, a Python agent that communicates via the HTML contact. Agents can be placed into a group at install through command line flags or editing the agents in the user interface. These groups are used when running an operation to determine which agents execute abilities. In addition, groups determine whether an agent is a red or blue agent. Any agent that belongs to the blue group will be accessible from the blue dashboard, while all the other ones will be accessible from the red dashboard. Abilities and adversaries are the MITRE attack technique implementations which can be executed through our agents. So the commands that would be executed, the compatible platforms, for example, PowerShell, Windows Command Shell, Bash, the payloads to include, and the reference to a given module. Adversary profiles are groups of abilities showcasing TTPs attributed to a threat actor. Selecting an adversary profile determines which abilities will be executed by the agent. An example would be what you see here. So we have, what do we have? We have the ordering here, of course, the name of the, it looks like the name of the tactic itself, or the name of the potential technique. This would be the tactic that it falls under. Or maybe not, because this actually is the tactic. This is the technique. I don't know what this would be. Discover local host, I guess, would be the name of the adversary profile. There you go. So this is the name of the adversary profile. This is the tactic that it connects to for MITRE. This is the technique that it connects to for MITRE. The executors would be Windows in all of these cases. Any kind of requirements, I guess, unlocks, payloads, cleanup, all of those things are included here. And we can look at them in a variety of different cases. This is Alice 2.0, which is the adversary used for demoing restricted lateral movement. So that is that. Then we have operations, as the name suggests. They run abilities on agent groups. The adversary profiles define which set of abilities will be executed, and agent groups determine which agents those abilities will be performed. So during the execution, the planner can determine the order of abilities. A few examples of these are detailed below. So we have abilities are executed based on the atomic ordering, so very similar to the atomics of Atomic Red Team. Then we have batches, which are abilities executed all at once, and then buckets, which are grouped and executed by the attack tactic. So, given these options, the planner feature allows users to control and give variations to the execution order of abilities during operations. And aside from the given terminologies above, you may need to also understand a fact, which is an identifiable information about the target machine. Facts are required by some abilities to execute properly. Hence, they should be provided through fact sources or acquired by a previous ability. Obfuscators would be the sets of obfuscation of each command before being executed by the agent. And then jitter is the frequency of the agents checking in with the Caldera server. So facts, I mean, it seems to be like a fact would be this is the IP address or this is the operating system version, etc. I'm not sure, but I think that's kind of what we would need, because it says they should be provided through fact sources or acquired by a previous ability. So it seems like you would be doing reconnaissance essentially to find all of your facts and then provide them so that the ability could actually run appropriately. And then we have plugins, which since it's an open source framework, it's very similar to distributions on Linux. A distribution could be extended by different plugins. So this way, we can also have extensions to Caldera by different plugins that provide additional functionality over the core usage. By default, it contains several plugins at users' disposal during adversary emulation, and these are some of them. So Sandcat, which is what we talked about, one of the agents, it can be extended and customized through the functionality. training, a gamified certification course to learn Caldera. That's very nice. Response, autonomous incident response plugin. It will be discussed later in this video. And then we have human, that allows users to simulate human activity, which may provide a benign and realistic environment. That's very interesting. So to learn more about this, we could actually go to the link that is available, which seems to be the Caldera's direct website. So from their direct website, we have the plugin library. So if you go to caldera.readthedocs.io, which is right here, and then from here, you should be able to go to the plugin library through the left-hand menu right here, and then you can choose Sandcat or any of these other plugins that are available. And that should be kind of fun to run with. So I can collapse that, and then that's what we can see. And then we have a variety of other things that are available inside of this side menu as well. So this is what we have for the plugin library. This is the full extent of it. And we may need to reference this, so I'll just leave that open for the rest of the video. What is the name of the agent that has the ability to communicate via HTTP, GitHub, GIST, or DNS tunneling? And it was Sandcat, I want to say, I think. Is that what it was? Sandcat? Yeah. What functionality determines the order of abilities execution? What functionality determines the order of abilities execution? And that would be our planner. So that's the one that determines the order. And that's very common sense name. So I like that. What is the name of the plugin that allows the simulation of human activity? And what is that called? It's called the human. It's so weird. Interesting, weird. It's kind of, I don't know. I don't know how I feel about that. Okay, so let's talk about running operations with Caldera. And now we are going to launch our virtual machine. All right, to actually be able to pull this off, we need to understand how the whole concept of the agent server machine and everything like that works. So to be able to emulate a single adversary profile, we have to run the Caldera instance, deploy an agent in the target machine, join the adversary profile, or excuse me, choose the adversary profile, and review the abilities to be executed, run the operation, review the results. So connecting to the instance, it's done via the attack box. So Caldera instance running via the attack box Windows machine that serves as the victim machine, which is what this button emulated. So this is going to be our victim machine. And then I already started the attack box from the very, very top. This originally said start attack box, and now it's going to be available in the split view. But because I'm super zoomed in, I'm not going to look at it right now. What I'll do after I read these instructions is that I'm going to zoom out of the screen, and then we'll just open up a brand new window so we can be full screen inside of the attack box. And then that way we'll be using the Windows machine as the target, and then the Caldera instance is going to be run from the attack box. So this is what it looks like in the diagram format. So this is me, or you, the user, right? The attack box virtual machine is the Linux machine that we're going to end up using. And the virtual machine, the Windows machine, is going to be our victim server. So I'm going to RDP access to deploy agents on the Windows machine. So it'll be one terminal where we actually use xFreeRDP to do it. And then we're going to run Caldera in the attack box and connect it via port 8080. And I'm guessing all of these things are going to be explained to us. Hopefully they'll give us some kind of instructions to be able to pull this off, and I don't have to go ahead and do a bunch of independent research to learn to do it. But I mean, it's this concept, this whole concept of having an agent and then having the victim, all of these things is pretty common in cybersecurity. So it's not something, hopefully you've seen this before and it doesn't freak you out or anything like that. If you have not seen this before, I would recommend going through some of the beginner stuff so you have a really good understanding of how interactions like this are ran, because this is technically a hard level room and you should have some kind of understanding between how these things operate. Just kind of going there. So VNC access via the web browser is going to be through the attack box Caldera instance via port 8888. This says 8888. This one says 8080. So that's going to be something that I'm going to have to figure out. And then the victim server access is going to be remote access via RDP to the victim server, which is all easy to do. The deploy of the victim server will be done using this information. This IP address is going to change by the time that I'm done with this recording. So if you're going to try to do this, you're not going to have any success because this machine is going to be taken down by the end of this video. From the attack box, we're going to run these things. So we're going to go to the actual Caldera room folder. From here, we're going to run this command. So the source is going to be the virtual environment, and it's going to be activated for Caldera. So first we're going to do that. This is very, very similar to what we do with Python when we want to run something in a controlled environment. So we create a virtual environment for it. And then, so we have right here inside of the, oh, there we go. And then they're going to run a Python server. So great. So we are now actually going to be using the Python version of this, which is nice because I'm pretty familiar with Python. We have executed source to, which indicates that we are using a Python virtual environment. Hey, and it's going to load all of the modules required by Caldera. And we got to wait a few minutes, which I've already done. So hopefully all of these things are actually going to be live by the time I'm done reading this. Once the output shows all systems ready, you may access the Caldera web application via the attack box port 8888 using the following credentials: red and admin. Deploying the agent. So the next step would be to deploy the agent and establish a continuous access to the victim machine. To deploy an agent, navigate to the Agents tab by clicking on the Agents button in the sidebar. Then deploy a Manx agent for a Windows platform since the target machine is running Windows. And so we will be doing all of this here. And again, I'm going to redo all of this. I'm reading all of this just so I can kind of wrap my mind around it. But we're going to rerun all of these instructions in a live environment so you can actually see me run it. Then ensure that the IP address in the configuration is set to the attack box IP address since the default value is this. Doing this will ensure that the agent will communicate back to the Caldera instance. In addition, you may want to replace the agent's implant name and customize it with a more realistic process like Chrome or Google Chrome, etc. Where's the implant name right here, which is Chrome, I guess. Then we have the Windows command line of a reverse shell agent, which communicates via the TCP contact. So the server will be the attack box on that port, and then the socket will be the attack box on this specific port. And then we have the get process, which means it's going to get the Chrome executable and this whole thing, which is, it falls under what? It falls under the data element. So WC download data URL, and then all of this seems to be the value that goes under the data variable that we have over here. The commands above were replaced with the values that you have set. Lastly, we're going to copy the first set of commands from Caldera to establish a reverse shell via TCP contact and execute them via PowerShell inside the server. So the set of commands below is only, for example, use the commands from your own Caldera instance, which is basically what we see right here, right? So this whole thing is what we're going to be running inside of PowerShell on the Windows machine. And 10.10.16.23, is that actually the IP address that I've been assigned? I'm very curious. 10.10.159.74. Okay, so that's definitely not it. So yeah, usually it pre-fills the IP address, but this really is just an example of the commands that would be run inside of the Windows PowerShell from the victim machine, right? So that we can have that reverse connection. So once done, an agent will spawn in the agent tab showing that the executed PowerShell command yielded a successful result. Now that the agent is running on the victim machine, let's review the adversary profile. And so we're going to go to the adversaries tab via the sidebar and use the search functionality. We're going to run the enumerator profile, or I guess for this specific test is what we're going to be doing. It showcases 5 abilities to be executed. They can be reviewed to verify the commands to be executed. It's an essential step in learning the expected results of the test. You may click on the abilities to see the execution. For a quick example, we can look at WMIC process enumeration. As highlighted, the 2 fields are significant in understanding which is the executor, and then which is going to be PowerShell, and then the command field, which is the command line, the full command that's actually going to be run. So executor is PowerShell right here. The command is WMIC process, get executable path, yada, yada, yada. So executing operations. Now that we've selected the profile to be executed, we're going to start the operation. We're going to go to the operations tab, click operation, fill up the details and expand the configuration by clicking advanced. And there are 3 things in creating the operation. First, you have to select the suitable adversary profile, which enumerator profile would be the one in this case. Next, you should select the right group. By selecting red, you will only execute the abilities using the red agents and prevent running the operation on blue agents if there are any. And lastly, the commands will be executed without obfuscation. So we can see Adversary's enumerator, groups is going to be red, and the planner is the atomic. Obfuscator would be plain text in this particular case. I think that's what seems to be the chosen element, and everything else has not been messed with. And then we click start. When we click start, you can observe the agent executing the list of abilities individually, and then we can have this right here, and then we can review the results by looking at the view command or view output portion. Caldera operations page may show that some abilities failed to execute. You may rerun the operation if an ability fails to execute or continue with the next task. That, I guess, is up to you. What is the default IP value shown during the configuration? That would be 0, 0. Oh, let me make sure my Bluetooth keyboard is now running. There we go. 0, 0, 0, 0. And there's that. How many abilities are included in the enumeration profile? So we could probably see this actually from the screenshot right here. So if we go to the enumeration profile, I want to say it's 5, unless they like completely cut this off in total. So we can say 5. Let's see if that's actually the answer. And it is. Now, what is the command executed by the task list process enumeration ability? That I need to actually go get, because I don't think it's definitely not going to show it. So that we need to run to be able to pull off. And then based on the executed operation, what is the name of the ability that did not provide an output? And then we need to also run that. So now that we have all of this, what I'm going to do is I'm going to zoom out of this whole thing, and we're going to start doing the initial setup of all of this, which was the initial connection of the agent and setting up the server, etc. So now I can click show split view. I should have my my attack box machine that's already up and running. I can see that the virtual machine, the victim, is already up and running as well. So that's going to be the IP address that we're going to use for that. And so we have now our attack box machine, and I'm going to open it up in full screen so that you can see everything easily on this side. And I'm just going to open up the instructions for the Caldera room in my second monitor, so I can just run through them without having to switch back and forth all the time. So let's first open up the terminal and connect to the Windows machine real quick. My favorite way to connect to a Windows machine from Linux via the command line is to use xfreeRDP. There are a lot of different ways to do it, but this one seems to be the one that is most consistent for me, and really the simplest, really. So you do xfreeRDP is how you call on that command or call on that tool, and then we will do /v, and then we will give it the IP address of the machine itself, which for me is going to be the, what was it? I think it was, let me make sure I load that real quick on my second monitor so I have that available. So it's the 10.10.159.74. So that's the IP address, which goes under the /v. And then from there, we will pull up the username and password, which was administrator emulation 101, which is, I think it was actually the same username and password on the other one. So, so then we will do /u for the user, which is administrator, and then administrator, like that. And then /p for the password, which is going to be emulation 101, exclamation. And we press enter, and it's going to say, are you sure you want to do this? And we're going to say, yes, I trust the certificate. And then once that's done, it'll actually open up a new window. And unfortunately, this can't be expanded any further than this. So this is it. This is going to be our target Windows machine that we have running in the background. So this I can't close, because if I close this, I think it'll also close the RDP instance that we have. So we're going to just leave that back there. I'm just going to open up a new terminal, and within this terminal is going to be where the commands for the connection of our Caldera agent, or the Caldera server, I should say, is what's going to happen. So first we need to go to the rooms Caldera /Caldera. So let's do that, and it's kind of lagging a little bit, so let's give it some time. We'll press enter, and then inside of the room, if we have run an ls real quick, we can see that we have the Caldera virtual environment that is available here. And where is that piece? Because that's very important for us to be able to use. So I guess it's not, it's in the previous one. So if I do ls of my other folder, which is this folder right here, when we look at what's inside of this folder, we can actually see the Caldera virtual environment. And then inside of the Caldera virtual environment, there should be a binaries folder. And then inside of that, there should be an activate. And so all of these things are available. Usually, this is what it looks like when you go through any kind of Python project. There's always going to be a virtual environment folder. And then inside of the virtual environment folder, there's going to be a binary. And then inside of that binary folder, there's going to be something called the activate file. And then so when you do that, what it does is it essentially activates the virtual environment. So you can run everything in that specific virtual environment without affecting the rest of your machine. So in case you've never messed with this, that's kind of what we're doing here. So we're going to do Caldera _venv, and then we're going to do binary or bin, and then we're going to do activate. And that's it. When we use that with the source command right here, it turns the source of our window. Where's my mouse? It turns the source of our window, of our terminal right here. It makes the source of that this virtual environment that's been created previously for us. So we're going to press enter on this, and now you can see that the command line has actually changed, and it looks like, or it shows that we have the Caldera virtual environment, which is perfect. So that's great. So now we can launch the server Python file, which is what we see right here. This server Python file is an executable that is going to be essentially going to be our server. And so we'll do, I guess, insecure, because that's the flag, the option that they chose when they ran it. So I'm going to run this thing and give it a quick second to actually activate the server. And then we'll run to the next set of instructions here. Okay, cool. So there we go. We got the message that all systems are ready. So the way that we should be able to do this is to go to our Firefox browser. And from there, I can either do localhost at port, 8888, I think is the port that they said. We could either do that, or we could actually do the IP address of the attack box, which is the 10.10.80.199. You see it right here. So for you, if you're doing this on your own computer, right? So the target machine would be the IP address that's for your Windows instance in this case. So whatever your secondary Windows computer would be. So that would be the one that acts as the agent. And then your main computer's IP address is going to be the IP address that you will have run all of these commands with the Python server, etc. And then from there, you should be able to just access the server by just going through your local IP address. So for me, it would be HTTP, and then we're going to do 10.10.80.199. I can probably also just do localhost, like the words localhost, 10.10.80.199, and then we're going to do 8888. That should be the port. So let's see if that's actually it. It says login Caldera. Okay, cool. We actually got it. So there we go. So it's not, you see, it's not that complicated. You know what I mean? It's this whole thing, it kind of seems a little bit, if you've never done this before, it's a little bit overwhelming to think about, but that's it. So username is going to be red, password is going to be admin. We're going to press enter on that and give it a quick second to load that. And there it is. Welcome to Caldera, join a stack, start training. I don't need to do any of those things right now. We're just going to go through the instructions. But it is nice that like at the very, very first load, it says start training. So that's a very, very useful little element that is available to us as users. So startup messages, requirement, Go version needs to be this, which I guess, I don't know if that means that I don't have a Go version that's greater than 1.11. And the requirement optional for UPX version needs to be that, greater than 0.00. So just basically anything better than the nothingness. Okay, cool. So we have the victim machine loaded. We have the server for Caldera already running, which is all great. So now we're going to start going through the process of deploying the agent. So at the very, very left-hand side, there's agents. We're going to click on that. and then we're going to click on deploy an agent, which is the very first red button right there. And then it says choose an agent. So I will go ahead and create the one where they said we're going to use the Manx one, I believe. So let me just confirm that real quick. Yes, it is Manx. So we're going to use the Manx, which is a reverse shell agent. And then we're going to use Windows as the platform. And now we are on this screen, which is exactly where we need to be. Now, from here, it says we need to change the IP address of this to the attack box's IP address, which is this 10.10.80.199. So let me actually kind of drag this a little bit to the left so I can kind of navigate back and forth between my two screens easily. So this is what we have. We're going to zoom in a little bit more so you can see what's up. So on app contact HTTP is going to be where I'm going to change this to the IP address of my attack box, which is the IP address at the top right here, that 10.10.80.199, and it's still going to stay 199. Yeah, okay. It's still going to stay on port 8888. So that part's going to be the same. And on the app contact TCP is also going to be that thing, and I guess I'm still leaving it on the 7010 port. So 10.10.80.199 is going to be the TCP contact, and it's going to be on port 7010. The agent's implant name, it says Splunked, which, I mean, I don't mind doing that, but the agent's implant name for my case, I guess I'll just do Firefox. I'll just do that, the agent's implant name. And the agent's contact UDP is going to be, again, the same IP address on port 7011, so 10.10.80.199. And that should be it. Essentially, that should be the only configurations that we would have to do. Now, if we scroll down on this, we should see that all of these things have actually been updated for us. So 10.10.80.199, 10.10.80.199, and then TCP, and then the name is Firefox EXE. So it worked, you know, it's basically what we got, and it's a PowerShell script that's been created for us because we're going to be running this on a Windows machine. So now what I can do is I can essentially just take this whole thing, because I think that's that's the full thing. So we're going to highlight this whole thing. Let me make sure I got, oh, there we go. See, there's some other stuff at the end of it that was not available. So what if I do Control A? No, it's going to highlight all of that. Okay, so that's kind of annoying. So we're going to do this, and we're going to go to the top here and go at the beginning. I need to make sure that this whole thing is highlighted, because that's going to be a pain in the butt if it's not. And then we're going to copy that. Then we're going to go inside of the Windows machine, our victim machine. We're going to open up PowerShell, and we're going to do Control V to paste the whole thing so we could see that it's actually been launched, or it's been pasted correctly. And now, for the moment of truth, I'm going to press enter. Okay, so I had to enter or press enter a couple of times for it to actually process, and then now it gave me the command line prompt at the very beginning again. So now we go back to our location here, our Caldera instance, and then we need to go to our list of agents. So we're going to click on agents again. I guess I could have just also refreshed the page. So let me refresh the page, and let's see what would be available under my agents. And it says you must deploy at least one agent. I have no agents, so that doesn't seem to be right. Okay, so let me see if this, maybe I did it incorrectly. Maybe that's the issue. I think I did everything exactly that they told me to do. So let's see if there's anything else that may have been missing from my initial instructions here. Okay, so I ran it again. The one thing that I think was a little bit different this time around is that when I copied the command, the way that it came through, and I don't think this really matters, because in the example that they gave us on the outline right here, the version that they ran also had no like new line. It just started with immediately if yada yada yada, and then it went through the rest of the command. So I don't think that piece of it really matters, but the way that this looked exactly the same thing, I did nothing different as far as the configurations of this is concerned, and still same IP address, same name for the Firefox, all of that was the same. The only difference is that there were just a couple of empty lines at the very end and one empty line at the beginning That's the only difference. I think that means nothing. I think I just needed to rerun the command again. And so this time around, as soon as I pressed enter, it actually popped this thing right in the background. So I didn't have to refresh the screen or anything like that. So it immediately just showed up in the background. So we got it. So we actually have our victim host that's been set up, and it's alive and it's trusted, which is nice. Cool. The group itself is the red group. Platform is Windows. Contact is TCP. PID is 5772. Privilege is the user, and last seen was just now. So all of that is great. Now we can move on to the adversary profile. So we're going to click on the adversary profile here, and from the adversary profile, I guess it says that we can select one, right? So navigate to the adversary tab and then choose a profile. We're going to select the enumerator profile. So we're just going to go over here. I'm just going to type in enumerator because it's so much easier instead of scrolling. And so there we go, enumerator collection discovery. So we're going to select that. There we go, we got that. And once we have selected that, it showcases 5 abilities to be executed. Each ability can be reviewed to verify the commands. And it's very important, I guess, to kind of see what is going to be ran in the background by this whole thing. So let's kind of max out the screen here. So if we look at each one of these things, you just click on them, it'll bring this pop-up up for us, and then so it loads usually at the top like this, and then you kind of scroll down. So you can see the executor, which is the PowerShell here, and then we have the command wmic process get, and then we can just kind of look at the rest of them. So this is the task list, and again it's PowerShell, so task list, app data VM tool, and then we have the next one, the PowerShell enumeration, it seems. And so get process, and it's going to be the process enumeration. And then UAC, user access control status. So it's going to just echo to get the user access control status. And then sysinternals, this is like the most complex command that exists inside of this whole thing, which is going to go ahead and pull information about the sysinternals. So PS tool process discovery is what it's doing. So the tactic under these things would be collection, discovery, 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 and then collection. And these are the techniques that they would be associated with. So that's basically the list of our adversary profile techniques that are going to be used. Now, I don't think I need to do anything other than this. I've just selected the profile. And now what we can do is move on to executing the operation, which would be under the operations tab. I don't need to do anything with the abilities. Based on the instructions, I don't need to do anything else. So I'm just going to run into the executing operation. So we're just going to go here. We're going to click on operations on the left hand side here and select the operation. So first you have to select the suitable adversary profile, which is enumerator, I guess. Let's see. So we're going to go over here. We're going to create operation, excuse me. So for the create operation, there we go. So in this case, we're going to create the operation, and we need to click on advanced over here to expand this whole thing. The operation name will be what they did. So I'm just going to do emulation trial 1. That'll be the name that we'll have to this. The adversary is the key piece right here, which is the enumerator element. So enumerator right there. That's going to be the adversary. The fact source will be basic. The groups will be the red group. Planner is still going to be atomic, and plain text is going to be what we have over there. And that's pretty much it. I think there's nothing else that I need to do in order for this to actually run. So what I can now do is I can click start, and we can kind of sit back and see how this thing works. And there you go. It's already loading, and it's already going through it. So I'm going to let this run because I have no idea how long this is going to take. So I'm going to let it run instead of trying to talk over it, and then we will see what happens at the very end of this. And we do have a question that says, based on the operation, what is the name of the ability that did not provide an output? So we're going to try to view the one that right here, there is no output associated with it. So let's let them run and see what happens. Okay, so after the first time that I ran this, which is basically, I think it was maybe like 5 minutes ago when I started running it, I see that the status on this is still running, but all of these things have gone through and completed. There is one that is failed, so that I may need to actually rerun this. And then when we're looking at the outputs, this one is nothing to show. And this one is also nothing to show. And then of course the failed one, it has something. So it actually has some kind of an output, but it was failed. And I'm not exactly sure if or which one of these would end up being the answer for us, right? So because we actually have two that have no output. So I'm going to run this again. I'm going to stop it here, and then I'm going to run it again. And then based on that, we'll hopefully get a better response. So let's run this one more time. Okay, so the second time around, we actually got a success message on all of the different tests that were ran, or the abilities that were ran. And now I get to see if all of them actually have an output as well. So we're going to do view output. This one actually has an output. We're going to do view output. And that has an output. That was the second one that previously didn't have anything and just had an error message. Third one also has an output. The fourth one, oh wait, it had an output, but then it just kind of vanished into thin air. So let's try that one more time. That's interesting, but that did actually have an output. Like briefly, it showed something. And then the fifth one also does not have an output. So that's so weird. The fourth one actually kind of for a quick second, it gave me an output. So if I look at the view command of it, it says get UAC. And so that was the command that was ran. And then looking at the output itself, that's so freaking weird because it literally showed something, like something was on the screen before it completely vanished. So, okay, anyways, we were able to successfully run it, and we were able to get 5 success messages. Now, it is still saying that this is running. So technically, it could be because of that. And usually there's a graph at the top right here that's telling me that the machine is like doing something in the background. There's processing power being used. So it could be that it's still running, and maybe I will get some kind of an output that will happen in the next few minutes or something like that. But for now, I'm going to just let this run, and we're going to go back here to try to see if we can find an answer to any of these questions that we have. So what is the command executed by the task list process enumeration ability? So we're going to go here, task list process enumeration. We're going to look at the view command, and we have this full thing. So I'm just going to copy that command from the task list process, and then we're going to paste it here, and that should be our answer. And then based on the executed operation, what is the name of the ability that did not provide an output? So let's go back and view these guys. Again, that one, you saw it. Like if you go back and you kind of freeze the frame real quick, you should see like something. See, it happened again. As soon as I clicked it, something showed up and then it just disappeared. So it feels like there's something there, but it just won't show it. And then on this one doesn't have that kind of a glitch. It just doesn't show anything. So I'm just going to use this because the UAC status, for whatever reason, it keeps kind of hinting that there's something, and then it just disappears real quick. So there we go. We're going to copy that, and then let's go back here and just paste that. And it does fit the formatting of the answer here as well. So that may be actually the answer that we're looking for. So let's do this, and there you go. That is actually the answer. Excellent. Okay, cool. So we are officially done with our first run at Caldera, and that was not all that bad. If you follow the instructions, everything should be fine. Even if in this portion your agent is going to be a Linux agent, as long as you just put in the IP address of the attack box machine, which is going to be the machine that this thing is connected to, right? So as long as the Caldera instance, whatever machine that's running on the browser, you use that IP address to modify this portion. Whatever you're going to get in this code is going to be a Linux version that you're going to execute in Bash or something. And then you just copy that, and then you go into the Linux machine, and then you paste it, and then you'll be able to run it very similar to what we did inside the Windows machine. And then it should show up on our portal, on your portal of Caldera, that, hey, now you have a Linux platform machine that has been connected, and then the rest of it will be exactly as it is. So none of the other things are going to change, with the exception of you're just going to choose Linux, and then you're going to go through the process for getting the code to establish that Linux agent and etc. So that was pretty good. It was pretty nice. Now we can go through the in through out task. In the last task, we executed a single adversary profile and the underlying abilities. And now we're going to customize the framework and emulate an attack chain that traverses from initial access to achieving the objective, which is, it's the entire attack chain, really, honestly, when you really think about it, like the Lockheed Martin attack chain. So if we actually go ahead and look at it, so Lockheed Martin attack chain, and maybe it's not the cyber kill chain, I guess I can call it. It may not necessarily be the full thing because it does include reconnaissance, weaponization, delivery, but essentially the action on objectives is the last step of the cyber kill chain. So when you go to initial access, you have gone past reconnaissance and things like that. So you have everything that you need to achieve the initial access, and then every other element of it is as it like just progressively advances toward through the attack chain itself. So initial access would be spear phishing attachment in the particular technique. Downloading macro-enabled phishing attachments would be the name of the ability. Execution would be Windows Management Instrumentation, WMI. So creating a process using WMI query and the encoded command. Boot or logon auto start execution for WinLog Helper DLL, the data link libraries. So that would be persistence, and that would be the WinLogon HKLM shell key persistence PowerShell ability. And then we have discovery, account discovery, local account, identify local users, collection, data staged, local data staging, zip a folder with PowerShell for staging in temp. And then, of course, exfiltration, which is the final step, which would be over unencrypted, obfuscated, non-C2 protocol, and exfiltrating hex-coded data chunks over HTTP. So modifying the existing abilities is the skill that we're focusing on in this particular element. So some abilities may require downloading a file from the internet, and the provided victim machine does not have an internet connection. So we're just going to keep that one in mind. Because the last video, I spent like a good 15 minutes waiting for one of the atomics from atomic test to actually run, because it just kept trying everything and it needed a internet connection for everything, and for 15 minutes it kept trying and it failed ultimately until it ran its course. And yeah, it was a whole mission. So we must review and modify the abilities to accommodate our network setup. So you may navigate to the abilities tab and use the ability names from the table above to check the commands executed by each ability. The image below is an example for download macro-enabled phishing attachment. So that's the name of the ability that we would be searching for. So you search for it, and then this is what pops up, okay? You've observed three things about it. So exfiltrating hex-coded data chunks over HTTP, download macro-enabled phishing, and so this piece right here doesn't exist. So if assuming that we search for all of these steps, right, this is what they're saying. So you've observed three things upon checking the abilities. This one doesn't exist. This one requires downloading a file from the internet, and zip a folder collects data on a non-existent folder in the target machine. So since the first item requires creating a new ability, let's focus on modifying the existing one. And we're going to review the command executed by download macro-enabled phishing attachment. And the URL variable is the specific piece that we're most interested in. So it's a GitHub repository from Red Canary, Atomic Red Team, Raw Master Atomics, bin phishing attachment, and then it's going to have these various invoke web requests of the URL, etc. So based on the code, it attempts to download the file using invoke web request. In addition, it configures the PowerShell session to enable SSL connection using the line, the service point manager security protocol, and then TLS 12. It might be TLS 1.2, but I think it's like TLS 12 specifically. So TLS is a more advanced version, or we can call it a more sophisticated version of secure socket layer. So SSL encryption is just another layer of encryption. So since the command attempts to download from external source, we need to replace this URL reachable by the victim server. So we can set up a Python HTTP server on our attack box, open a new terminal in the attack box, and execute this. So we'll go to Caldera HTTP server, and then we're going to use Python 3 mHTTP server on port 8080. So this is one of those things that we've done multiple times when we were doing the reverse shell exercises for pen testing. And the original file required from the GitHub is already hosted in the HTTP server directory, which is what we have over here. So we're creating the server inside of that directory so that the victim machine can just easily connect to it and download it. Now that we have a new URL, we're going to go back to this phishing attachment and replace the URL value with the attack box IP address, port 8080, and then just the path of the phishing attachment XLSM. And this is assuming that this location is basically this folder right here. So we're just saying that we're already inside of that folder because that's where we launched the server. And then from there, we're just going to leave the rest of it to be exactly the same. So you would do this inside of the command element of the ability that you would be modifying. To continue the modification of files, let's review the command of the zip-a folder with PowerShell. So compress archive is the commandlet that it's going to be using. The path would be the path to the atomics folder, and then going to the folder that it's going to zip. And then destination path would be an environment inside it, or environment variable inside of the temp folder, and that would be the folder to zip.zip, meaning it's actually been zipped, and then you're forcing it to just force through any of the errors. Based on the code snippet, it attempts to compress this document, and we can replace this with a new value like this specific document, which is the downloads folder, pointing to the current user's download directory. And to fully customize the command, we can also replace the target archive name with exfil.zip. So this is what it would look like. We would have path, and then this would be the environment variable that is going to be zipped, right? So it's going to zip that variable, and the destination path is going to be exfil.zip inside of the temp folder. So we must replace the target file in the cleanup script. The image below the image below summarizes the modifications made to the ability. So the command would be the compress archive path, and then we're giving it the user profile downloads, and in the exfiltration.zip, all of that is the edited command, and then the cleanup would be to remove the item that is that exfiltration.zip to make sure that we actually remove this specific zip folder that was created. So creating a custom ability, the ability exfiltrating hex over HTTP does not exist, so we have to now create this to be able to emulate that entire kill chain, right? The goal is to execute a command that exfiltrates the collected data from zip folder for staging in temp. So we're going to exfiltrate the data from this ability, or we're going to execute a command that exfiltrates the data from this ability. So to do this, we're going to use PowerShell, and we're going to hex encode the data, split it into chunks, and send it to the existing HTTP listener, which would be running on port 8080, that Python listener that we had. So the replacing of the attack box value below with the correct attack box IP address. So this will be the full command. We're going to replace this with our attack box IP address on port 8080, and the rest of it will be staying the same. The command executes the following. It reads all the bytes from the temp exfiltration.zip, encodes all of the bytes into hexadecimal, splits the hex data for every 20 characters, sends the data via a curl get request to the HTTP listener with the following command right here. That's what we have. So we're going to continue creating this and clicking the create an ability. So that's essentially what we're going to be doing. And these are the various fields and values that need to be assigned to it. So exfiltrating hex-coded data over HTTP would be the name, description would be this, tactic and technique would be this, singleton repeatable delete payload is unchecked, platform and executor is going to be Windows, a PowerShell, and command is going to be use the provided command above, which is this command from what I understand. So now that we have all of that, this is what it's going to look like, right? So this is the full create an ability values, and then when you go to the command itself, this is the command: environment variable exfiltration, destination HTTP attack box, etc., etc. So let me see. Environment variable file is environment. Is that what it starts at? It's file environment. Okay, so that's exactly the command that we're going to be pasting here. Once done, save the new ability by clicking the save button in the lower right corner. Create a custom adversary profile, and we're just going to go to adversaries, create new profile, and then we're going to do profile name, emulation activity number 1, profile description, and then after those we're going to click the create button. And then once we have that, we can now start adding abilities for each of the abilities that we want to emulate. So emulation activity 1 will add an ability, and then we will search for the ability that we want to add. In this particular case, let me just make sure here. So once we add an ability, we can search for it, and then we're going to download macro enabled phishing attachment, create this winlog. So we're going to add each one of these in order. And once you've selected it, you click save and add to append it to the adversary profile. And this is what it should look like finally, where we have 6 abilities that have been added to it that should be ran. And then from here, we can now click save profile, that green button over there. And it'll save the profile, and then we can run the operation and review the results as such. So let's see, what is the name of the file downloaded by the first ability? The name of the file downloaded by the first ability. And so this, I think it was actually even, let's see if it is the ability that I think it was, because from there, the spear phishing attachment downloading would be from this GitHub element right here. So it would technically be this phishing attachment XLSM. And this is the one that's already been provided to us inside of our folder on the attack box. So we should already have that. So that's going to be the name of the file that should be downloaded by that phishing attachment. So let me see if I can, there we go. We can now paste that. What is the name of the new process spawned by the second ability? So if we go to the ability profiles here, see what the new process that's going to be spawned by that second ability. Where is the list right here? Okay, so for this one, I believe we actually have to run the exercise. How many accounts were identified by the 4th ability? We got to run it. What is the name of the directory archived by the 5th ability? That would be the downloads folder that was being archived. How many HTTP requests were made by the 6th ability? And we got to run that as well. HTTP requests are logged on the listening HTTP server, so we got to actually run it. All right, so starting from the top, let's zoom out and go to our attack box and run it. All right, so the first step from this whole thing is to be able to provide a server for our victim machine to actually be able to connect to be able to download the attachment and do everything that it needs to, which is this whole piece right here. That's for the download macro enabled phishing attachment. So the first thing that I'm going to do is I'm going to go into my attack box, and let's minimize this right here. Go right here. This is what we had that was running the, what is this? This is the one that's running Caldera. So that I'm going to keep, and then this is the one that's running the victim machine. So all of these things we're going to keep. So we have to open up a third terminal here. And inside of the third terminal, we're going to go to the location, which is the rooms Caldera HTTP server, like that. And inside of this, we should be able to, yeah, there's the phishing attachment. So now we're going to run the server. So it's basically a very simple command, and just using this, as long as you have Python 3 enabled on your machine, you can just turn your machine into a server, and any data could be downloaded from the server. And you do it using this very simple and easy command. I love this command. We've used it so many freaking times, let me tell you. So there we go. Now we have it, and now it says serving. Hey, serve, honey. Okay, here we go. So serving HTTP on port 8080 on our attack box IP address, which is that IP address that we had at the very beginning, this 10.10.80.199. That's the IP address. So very good. So now we have our server running. So now we can go back to our download macro enabled phishing attachment and replace the command with the link to our IP address. So we're going to go to the folder right here, back in our, not the folder, I guess I should say, this whole piece right here. This is still running, by the way, which is kind of annoying. So if I click on view output, that still doesn't have anything. So I'm going to stop this from running just to kind of preserve the processing power of our computer. And we're going to go over here under abilities, and we're going to click on abilities, and we're going to now, let's see, I'm going to search for the download macro enabled one so I can customize it. I think that's the big piece that I'm supposed to be doing. So once we have that server that's running, we have a new URL, so we can navigate back to the download macro enabled phishing attachment and replace the command field with the new value. Okay, so that's exactly what we're doing. So we're going to go here, we're going to search for the download macro, There we go. Macro enabled phishing attachment. There it is. So there is the thing, and this is what we got. So we're not doing anything with the exception of just scrolling down, and we're going to modify the command line a little bit to replace our phishing attachment link with the IP address of our virtual machine. So this is going to be, this whole piece right there is just going to be replaced with the IP address of my virtual machine now. It needs to also be an HTTP because I am doing it on an insecure server, which is my basic attack box. And I'm going to do 10.10.80.199 and then / phishing attachment. Oh, actually, I do need to do port 8080. That's the other piece right there. So I should have now the same thing right here. So at 10.10.80.199 on port 8080. So if we go and pull up our terminals, the most recent terminal was this one. So that's not the one that I'm looking for. Let me see, where's the one that I'm actually looking for? So let's minimize this again and go and look for our multiple terminals. Right, okay, so there we go. This is the one right here. So port 8080 is the location indeed. So, all right, cool. So this is the only thing that I believe I need to change. Apart from that, nothing else needs to be changed because I'm just modifying the URL to be that. And the command itself, so what does it say? It says so what they've also done is they've actually removed the encryption element of it that actually enforces the encryption portion of it. So they've only left the invoke web request portion. So this whole thing is also being deleted because we don't want to enforce the encryption of this. So we're now going to change that. And now we are left with invoke web request. URI would be the URL. The out file is going to be the temp folder. And it is still phishing attachment XLSM. So all of that is done. So now we can go ahead and save this because I don't need to do anything other than save with this specific piece. So I'm going to go click here on my save button and let's make sure that it actually saves. And I think it did save, right? So it says, yeah, saved ability. Okay, so the ability has now been saved and we can close this. So we'll close that and let's click on it one more time just to make sure that it has actually been saved. And it is great. So it actually has the new URL and everything else is good. Okay, cool. So that one has been modified and we're good to go with that. The next one is going to be the zip a folder with PowerShell staging in temp. And it attempts to compress all of that. So we can replace this with a new value, which is the downloads folder that we want. So in our search right here, we're now going to search for the zip a folder with PowerShell, and there it is. So we're going to open this thing up, and the cleanup is remove the folder. So that's what it is. Remove item is the cleanup. So remove item path is going to change right there, and the command itself is also going to change, and is going to be the one that we're going to. The path of the thing that's going to be zipped is going to be the user profile downloads. So path is going to be env. Let me just make sure that that's actually right. Okay, that is actually correct. So what we're doing, because we're using the environment variable, it's actually going to just pull the whatever the user name is, and then it's going to do use like this. So if we do user profile like this, let me kind of zoom in here, and I did user profile. So spelling on this is going to be very important. So it needs to be user profile. Okay, there we go. User profile. Okay, that's spelled right. Nice. / downloads. So now it's going to look at whatever the environment variable is, meaning it's just going to look at the host name and the path that would lead up to the username itself, and then it's going to look at the downloads folder, and then the temp folder name is also going to be changed, which is instead of being folder to zip, it's going to just turn into exfil.zip. I'm literally doing it step by step as they outlined in the instructions. And then from here, we're also going to modify the cleanup command down here, the remove item path environment temp folder, So what I'm going to do is I'm just going to, again, just change this piece to our zip folder that we actually created, which is the exfil.zip. And then error action is going to be ignored and everything else is going to stay exactly the same. And so we're going to click save on this one. And that should also be good. And then one more time, I'm just going to click on it just to make sure that it actually is. and it is exfil.zip, and then we have user profile. Okay, perfect. So we have now modified our second ability. So for the next one, we need to create an ability because there's nothing that exists that we need to modify. So we're going to click on this red button that says create ability. And in this particular case, there's a bunch of data that we need to actually fill in for this. And the command itself is like the big piece that is going to be modified in our particular case using just our attack box, and everything else is going to pretty much stay exactly the same. But I do need to fill in some of these basic pieces right here. So for example, the name, description, all that stuff. So I'll just, I'll type it out because I kind of feel like typing, and I want to do like a time lapse because I always love the coolness of the time lapse typing stuff. So I'm nerding out here. So let me go ahead and type this whole thing out real quick. Okay, cool. So we got that piece, and then we need to make sure that we uncheck the singleton that's right down here. So that's a very important piece of it. And delete payload repeatable also needs to be unchecked. So all of these things over here need to be unchecked. So all of that is good. And now we can move on to the element where we paste the command here. So this is what it all looks like. The platform needs to be Windows. So I'm going to check Windows here, and the executor is going to be PowerShell, and for whatever reason PSH is not here. So there's shell, there's CMD, there's native, PWSH, which I guess would be PowerShell in our particular case. I'm just going to assume because it doesn't have PSH, it just has PWSH, and that still kind of sounds like it stands for PowerShell. The payloads I'm not going to mess with. All of those look exactly like the instructions that we got. The one thing that I do need to input here is the actual command. So the command I do have pre-written here, and this one is a very long command. So for this, I am going to copy and paste because there's also the element that I don't want to get it wrong and then spend time trying to fix the whole freaking thing. So this is the full command that we have copy pasted. Now the one piece that really needs to be modified is the attack box IP address, which is very, very important. So that's the excuse me, that's the one that I am going to change. I kind of didn't disclose this, by the way, but I'm totally under the weather. I don't know if you can tell, my voice is kind of deeper. I feel like Phoebe from Friends when she got sick and like she liked her voice. I kind of like my voice right now. It's like, it's raspy. I should be going, smelly cat, smelly cat. Anyways, moving on. There may be a little bit of delirium that's also coming from this little illness that I got, but it is what it is, my friend. So we do have our command, and the command seems to be perfectly fine as well because we literally just copy pasted it, and the only thing that I needed to modify was the IP address of the attack box, which I did. And so now we can actually move on to creating the custom adversary profile. So it has now been saved, and let me make sure that, because I think we need to refer to it by its name, which is exfiltrating hex encoded data chunks over HTTP. So this is now saved. Let's make sure it is saved. It is saved. Great. So we can close it. And now we actually have this. So let's see if we can actually find it by doing exfiltrating. Let's see if that actually shows anything to us. Okay, well, I can't search for it. So that's a little bit concerning. I'm curious if that would actually mess with anything or if it was saved or anything like that. So if I do exfiltrating, so I loaded the whole thing. If I do oh, there we go. There it is. Exfiltrating hex encoded data chunks over HTTP, and it has all the information that we actually put over here. So nice. We've actually created our own ability. That's nice. So now we're going to create a custom adversary profile. So we will now go back to adversaries. You can also, if you don't refresh the page, it stays up here. So you can go back and forth between abilities and adversaries and everything else by doing this. So we're going to go to adversaries. We're going to create a new profile by clicking the new profile button. We are going to name it, and we will do emulation activity number 1 as they put inside of their exercise. And profile description is this profile executes 6 abilities from different tactics, emulating a complete attack chain. And we will click create, and we have officially created the profile, so that's great. So emulation activity number 1, as you can see, it's over here. So now what we need to do is we need to start adding abilities to this bad boy. So ability right here, and then we're just going to go piece by piece, right, to make sure that we actually add all of the elements that we have. So I'm just going to add each one of them. I think I need to do the search, and then what else happens? I think essentially all I need to do is just search and then do save and add, and then just move on to piece by piece. So let me go ahead and do that. Let's see. Okay, so that was the creation of all of our abilities, or adding all of our abilities. And now we have this full thing. So one key piece is to save the profile to just make sure that it's actually working, and we got save profile at the bottom. So that's great. So now we can run the thing. So now that the new profile is ready, execute an operation using the emulation activity number 1 profile and review the results. So we will go back to operations here, and then select an operation is going to be emulation trial number 1, 5 decisions an hour ago. That's definitely not the one. So I'm going to create one, and it's going to be emulation activity, right? So emulation activity number 1, because the first one was the trial. And then right here, we're going to click on advanced. And pretty much, I think I'm going to do exactly the same thing. So emulation activity number 1, which is the adversary profile that I created. Fact source is going to be basic. It's going to be against the red group. Planner is going to be atomic. Plain text. All of these things are pretty much exactly the same as we had before. And that's it. So we're going to start it, and let's see how this goes. Okay, so one of our questions was, what's the name of the process that's spawned by the second ability? So I can already just kind of look at the output here, and then we can see what we potentially have. So starting code, nothing to show, standard output, 2 parameters, the name of the process that would be started by this ability. So it says nothing to show. So let me go ahead and look at the command from that ability, and it's going to execute bypass. And let's see, look at this, that's insane. I think for this, because that seems to be encoded, right? The full thing seems to be encoded. So I might need to just go ahead and see what potentially may be the value of this encoded piece right here. So let me copy this, and I just want to get a head start on all of our questions here. And we're almost done. So it has one more piece that it's got to do. So we're going to go to CyberChef, and we're going to paste this little block of encoded, and I think it was already hexadecimal encoding anyway. So that's what we have. Let's see what we can find with CyberChef. So it's actually base 64. It's not hexadecimal. It is a base 64 encoded string. And then so I combined 2 operations. We have from base 64 and then remove null bytes, because if you don't remove the null bytes, this is what it looks like, which you could still actually see. It's just that when you actually include remove null bytes, now it's fully readable. So invoke WMI method, path, win, name, create, argument list, notepad.exe. That's the name of the process that was spawned over there. So we'll just go over here and we'll do notepad.exe. And now it says how many accounts were identified by the 4th ability. And so we have the 4th ability right here. So let's go look at the view output for that 4th ability. And what do we have? We have the administrator, default account, guest, and WDAG utility account. So what is that? 4, right? It's 4 accounts. So let's see if that is indeed the answer. I think it is 4 accounts, yeah. So 4 accounts would be that. Excellent. And finally, how many HTTP requests were made by the 6th ability? And in this particular case, it says the HTTP requests are logged on the listening HTTP server. So if we go over here, and I need to actually do the 6th ability, because it's still not even running. It seems like it just finished the 5th one. So let's see what happens while the 6th ability is going to start running. So I will pull this terminal up front, and let's see what we get. It seems like it made 1 already. So this is the very first one to get the a phishing attachment, although that may be the very first one, because that was the first thing that actually ran, right? Because the first one was trying to download the macro-enabled phishing attachment. So that would technically be the first one, or the HTTP request from the first ability. So now we just need to wait to see what's going to happen with that sixth one, and then how many requests that thing is going to make. So I'm going to step away because it feels like it hasn't even started, right? So this is the piece that's kind of interesting here. I know for a fact that I added it. It can't possibly be that I didn't have it added. That's the one piece that I'm kind of like worried about. I thought maybe I didn't add it, but I'm pretty sure I added it. So let's go to adversaries here. Yeah, I do have a 6.1, exfiltrating hex-coded data chunks over HTTP. So I definitely did add that. I know that. If I look at it, destination IP address is also right, 10.10.80.199. That would be the attack box, so that's fine. So I did my part as far as that's concerned. And now we just need to wait and see if this is going to work. Okay, so this completed. However, it only completed because I made a little bit of a modification. So I actually ran this twice before I made the modification, and neither time in the first two attempts it worked. And then I went to adversaries again just to try to figure out exactly what was wrong. And I opened this last piece right here, and I went to the executor. And previously it was PWSH because for whatever reason when I was creating this, it didn't have PSH available. And then when I went in here to try to edit it, I saw PSH and I switched it to PSH and I saved it, and that worked. So yeah, when you do save and add, it actually re-adds the thing. So just keep that piece in mind. So you just want to remove one of them and then only have one version of it. And then I stopped it, and then I reran the whole thing. So I stopped it, I created an operation, and then I named it Emulation Activity 1B because I tried number 1 a couple of times without any success. So I was like, I'm just going to do this completely from the beginning. And so I created a new operation. I chose Emulation Activity, very similar to what we had previously. And by the way, so once I made this edit, I made sure to save the profile. So just do that as well. And then when you go to operations and you create your operation, you just want to make sure that you choose the one that you created, etc. The rest of the steps are exactly the same. Just make sure that you repeat everything to make sure that it actually has saved that final piece. And so it actually did save the final piece, and now we actually have a 6th step that was completed. So we are all good. And now we can go to our server here, and there we go. We actually have all of these HTTP requests that have ran for us, and I mean, this is a lot, so I don't exactly know how many has been done. So we can see the first 3 over here are the ones where it's retrieving the phishing attachment, and it actually had to do that every single time. And then finally it gave the last or the second series of actions, which was running all of those HTTP requests. So it's asking us how many it ran, and that's the piece where I'm trying to find out exactly. So I gotta try to find a way to count this without losing my place, because that's the part that's like a little bit challenging. So let me see if I can count this real quick. Okay, so there's 23 that I counted, and let's go see if that's actually the right answer. And it is. How wonderful is that? So officially we are done with this task, and that was honestly not that bad. The biggest part of it that was a learning curve was just choosing the right executor, however you want to pronounce it, and just make sure that you have PSH instead of PWSH selected, and apart from that, everything else should work perfectly. So now we can move on to emulation to detection. Now, essentially, we're going to be looking at the tasks that we're running from the perspective of the victim machine using Sysmon and Aurora EDR for our tools for detection. So the victim machine already has those things to log the events and detect malicious activity. And we're going to execute the emulation activity number 1 or re-execute emulation activity number 1, which is exactly what we just did right here. So we're essentially just going to redo this piece, and then we're going to look at the stuff that happens on the victim machine to try to detect everything, right? So given this, we will mainly use the provided RDP access to the victim server to conduct the analysis. Sysmon is installed and installing in the machine or running on the machine. The easiest way to open up Event Viewer, go to Application Services, Microsoft Windows, Sysmon. I'll show you what that looks like in a little bit. And an example image below shows the execution of create a process using WMI ability, and that would be event ID 1 for process creation. So we can actually see it over here. And then inside of the command line, we see the entire command that was ran from the Caldera tool, right? So that's what we're looking for, and most likely we're going to be going through that whole piece. So we're going to rerun the application using, or rerun the operation using the rerun button. We'll create a new operation using the same profile but with a configuration allowing us to run abilities individually. So the only difference from our previous setup is that the run state is set to pause on start instead of run immediately. So don't forget to start the operation by clicking the start button. So when we create the new operation over here, instead of saying run state, run immediately, we're just going to do pause on start. With this, you may see that the operation is paused upon start. And then given this, we can use the run one link feature to execute a single ability at a time. And then upon checking the logs after refreshing the event viewer, it only generated 4 events. And this is better than flooding it with overwhelming logs. And then you can go ahead and run through the logs. So you may proceed with executing the next ability, reviewing the logs, and other processes might generate some irrelevant logs. To have a clear understanding of the execution flow, you always start your analysis from the log that contains parent image Chrome exe. This is the process name of the Caldera agent. For me, it's Firefox exe. So I want to go through users public Firefox exe. That would be the parent image. And then everything after that essentially what we're interested in. So Sysmon log analysis via PowerShell. We can also use PowerShell to analyze the Sysmon logs. Alternative for the event viewer. And the way to do this would be to actually go into the tools folder and import the module clear win event PS1. And then if you have done it correctly, you should be able to actually see the help menu for the clear win event. And after loading the module, we can start looking at the same methodology of running a single ability. So we'll just go through the same thing again, run it once, reviewing it and clearing the logs. So let's continue by executing the following ability, which is this piece right here. So get win event log name Microsoft Windows Sysmon operational yada yada yada, and then it pulls the information for you and you can analyze it as such. I'm going to use the event viewer because I actually like the event viewer. In this, there's a lot of times where I prefer the command line for it, but the event viewer makes it a little bit easier to analyze events as they happen and clear the logs and so on and so forth. So 3 things after executing get win event command. We use the FL for format list to list the field value of the logs instead of the default table format. The printed logs must be analyzed from bottom to top to follow the correct timeline. And we redacted the file creation event of the PS script policy since it is insignificant to the analysis. You may disregard this log entry while doing the analysis. Don't forget to clear the logs again before proceeding to the next ability. That's very important. If you prefer analyzing the events in real time while the operation is running, we can use PowerSim PS1, which is a script created by IPSec. And it prints the logs every second, essentially. It just is a live scanner kind of a thing. It's PowerSim, right? So SIEM, Security Information and Event Manager is what I would assume that stands for, but it's being run through PowerShell. So it's a PowerShell sim, essentially. And then you could just run it. After you execute it, you can just do everything as you would normally, and then everything would be populated into PowerShell. And then finally, we have Aurora EDR, which is events that are generated using Sigma rules, as we can see right here. And instead of being in the same location as the Sysmon events, it'll be inside the Windows Logs application. And then from there, you can actually just narrow everything for the source to actually show you only the Aurora agent which is another way to filter it that makes it a little bit easier to analyze. So now that everything is set, we can re-execute the operation to review the detections made by Aurora ADR. You may need to create a new operation using the same profile to execute each ability individually. And again, you may clear the logs before proceeding to the following ability. Don't forget to refresh the event viewer once the ability has been executed. For a quick example, let's analyze create a process using WMI, and we can see that there's been 25 events generated. So let me kind of zoom in a little bit here. We can see that we have 25 events that were generated for the Aurora agent source, and then the warning element right there. And then essentially what I found is the warning ones are the most useful to us. So anything that has a warning label is the most useful. So Sigma rule matched, system event log created, see details for information, and then you go to details and it actually shows you the details of everything that it found, including what was ran and the details of the exercise, the ability that was running. So we must remove system event log cleared from the count since it is generated by our logs action before the ability's execution. You may navigate to the details tab of each event to analyze the detections, and such as the Sigma rule that was found, the suspicious parent process for PowerShell, for example, rule title, rule event, all of that, the path, preferences, company, etc., description. And I want to see, I don't think it actually shows us the command that was ran, which might be one of the things that would be interesting to us. Oh, there we go. It's under match strings. So it says why this activity is flagged based on the match strings field. So anything that shows up that's been here, that's been actually included here, then that's what's going to trigger the rule. So that would be like the closest thing that we can use to try to find the command line that was executed if you're going to use Aurora as your detection mechanism. The ability was flagged using suspicious PowerShell parameter substring, execute bypass, and of course PowerShell executable is all in the match string element. So execute bypass exists in the command line field, PowerShell exe exists in the image field. Reviewing this made it easy to understand the following commands above indicate potential malicious activity. So emulation activity number 1 analysis, we're going to do it one more time, and then now we're going to analyze it from the perspective of the victim machine, and then we're going to answer these questions here. So let us go to this piece right here. What I'm going to do is I'm going to open up my PowerShell. Actually, I need to minimize this to go into this element right here. And look at that. This has been created in the background because we ran that emulation exercise. Let me actually, and I ran it a few times, so it actually has this notepad that's been opened up. It's so cool that it actually works. When things work, it's always like very interesting. So we're going to stop this to just make sure that it's all good. And then I'm going to minimize this again. We're going to go into our victim machine. We're going to go into event viewer. And the first thing that we want to do is we want to clear the logs. So we're going to go to applications and services, or actually I think I'm going to do the Windows logs and use the Aurora agent as our helper. So once we are inside of the application logs for Windows logs, we are going to first filter the current log, and under the application that's being used, we can go ahead for event sources and choose Aurora as the specific agent that would be our useful tool here. So we can go under event sources and choose Aurora. Now this is supposed to be alphabetized, so there we go, Aurora agent. There it is. There's 2 Aurora agents. One of them is lowercase, the other one's uppercase. I'm going to pick both of them. And then we're going to do OK. And now everything should be filtered. And now we have 485 events, which obviously has a bunch of stuff that it was detected. Previously, I cleared the filter instead of clearing the logs. So let me do this one more time. And then from there, we'll go ahead and clear the logs. So there we go, Aurora agent. And then cool. And then clear log. And now it's going to say, are you sure you want to clear it? Yes, I do. Now we have 0 events in place. So let's go back to our web browser. We are going to now rerun this operation from the beginning. And actually, I forgot to, my God. Okay, so stop. I need to recreate this adversary. And essentially what I'm going to do is I'm going to modify it to Actually, I think it's under operation. So I'm going to create a new operation, and we're going to do operation 3. We'll just keep it like that. And then we're going to go to this piece right here where it says pause on start. And we want to make sure that red is selected. And for the adversary, obviously we want the emulation activity number 1. And everything else is pretty much going to stay the same, except just the run immediately is going to be pause on start. So I'm going to do this here. And now it should be paused on start. So it hasn't ran yet, technically. So I'm going to go back here. There are events that have generated because I actually did run the other thing. So now 13 events were generated for the other one. So again, I'm going to clear this. And then we're going to start from scratch. And we're going to go piece by piece, right? So that's the piece that hopefully will be a little bit easier for us to manage. So I need to kind of modify this to be able to see things a little bit easier. So I'm going to expand this. You can't expand this window. That's the one thing that's like really annoying about doing RDP or like remote desktop into a Windows machine, that you can't maximize the window. You know what I mean? Like it kind of just stays the same size. So you got to try to find different ways to improve your viewership. So, all right. So now we have a clear log. Oh, it actually shows I think it's the new item that has shown up. Yeah, it's the item that says event log cleared that triggers a response. So apart from that, there's nothing else right now. So I'm going to go back into the Firefox browser and I'm going to do run one link. So it should run the very first one. There we go. So it's running the very first one. So as that's running and now it's completed, let's go back to our Windows machine. And then now we can see that we have new events. So we will now refresh and we have 10 events in total. So let's kind of narrow this down a little bit. And there we go. So we have the Aurora agent and we have information level, date, time. Source is going to be Aurora agent. Event ID is what's interesting to me because that's going to narrow down a lot of things for us. And then we have the task category as well. So there we go. We have our 10 events that were generated after the first one. So it says, what is a value of the parent image from the first log generated by any ability? The value of the parent image from the first log generated by any ability. So for me, I think they're looking for the chrome.exe because that's what they used in their creation of the example. So we're going to use the chrome.exe, but for me, it's firefox.exe because if you remember, as we recall back into what we did at the very beginning of this, I didn't assign it chrome.exe. I just did Firefox because I thought it didn't really matter. But this is technically the value that they're looking for, which is the parent image. And that would be the thing that would be the very first thing that shows up. So there's that. And that is the right answer. Now, what is the name of the ability that generated a sysmon event ID of 13 during the execution of the first ability? What is the title of the Sigma rule that flagged the usage of invoke web request? And during the execution of the fifth ability, what's the value of that? During the execution of the sixth, what's the title of that? So we're looking for what's the ability that generated sysmon event of 13, and then during the execution of the first one, what's the title of the Sigma rule that flagged the usage of invoke web request? So we're going to go through all of our events here. This is after the first ability that was ran. So I'm going to look at the ones that have the warning signs. Usually the ones that have the warning signs are the ones that are most interesting to me. And so suspicious PowerShell parent, and then what is it? Potentially suspicious execution from parent process in the public folder. So let's open this one up and see if we can find the one that has the invoke web request inside of it. That would be the event of interest to us. Okay, so just to kind of, this is super slow right now. This virtual machine, this target machine is like really, really slow. So it wasn't either of these because these were the ones that were actually relevant to the image, the parent image of Firefox EXE. The second image right here, if you actually go, the general will kind of tell you what you potentially would be looking at. So this one says, PowerShell web download, see details for more information. So this would probably be the one that I would be interested in. Now I'm going to open this and it's going to take forever for it to open. But once it is fully opened and loaded, we can actually look at the name of, or I guess that would be technically the name of the thing. So it says, what's the name of the ability that generate? No, I'm sorry. So during the execution of this, what's the title of the Sigma rule that flattened this. So it's actually PowerShell web download. That would be the answer. I don't even need to go into that. So PowerShell web download is the answer for that. I don't need to go into it because just from the name itself, I can kind of understand that it's doing invoke web request, and we can deduce that information without going into it. But I've already double clicked it, so you see that it still hasn't even loaded. So there you go, finally. So it loaded the thing. I'm going to now click close, and it's probably going to take 2 minutes for it to close the freaking thing, and then we can just move on to the next one. So it says, what's the name of the ability that generated a sysmon event ID of 13? So we can technically move on from this one because none of these have to do with that first ability anymore, because the first ability did not generate anything that has to do with event ID 13. So then what I can do now is I can go ahead, and it's actually asking for sysmon event ID 13. So I feel like I should go to the sysmon events instead of being in the Aurora events. So I will now be navigating to the sysmon events, and that's going to take a minute because this thing is freaking slow. But once I get there, I'll show you where I'm at. Okay, just to show you how I got here, it's under Applications and Services. We go to Microsoft, then we go to Windows. And inside of Windows, if you click that arrow, it's going to do the drop down, and you'll see this whole list underneath this inside the sidebar. So I usually just click on Windows, and then this is where we find sysmon. You just scroll down to S, and then double click on that, and it'll open the logs for you. And then from here, we'll also double click on this to actually open the series of events, which is the 3,200 something events. And then once that's loaded, you can clear the log with the same exact button over there. So I'm going to clear this log, and I already cleared the Aurora log as well. And I just want to see if the Aurora log is actually going to show me the same event IDs. I think it should, because it should be operating based on the same event IDs. But we're going to go through the next step right here to see which one is going to generate the event ID of number 13. So what's the name of the ability that would generate that for us? So we're going to go here. We are done with this ability. So we're going to run the next one here, and that'll run one link, and it should be the next thing. And then once that runs, we can go ahead and check our events to see if any of them actually have the event ID of 13 associated with them. I've already extended the time on these virtual machines twice, so I think this may be what's causing the delay of this whole thing. Like the load, as you can see, it's kind of like painful, honestly, how slow this whole thing is running. But it is what it is. This is what we signed up for when we decided to use this. It usually is not like this. So here's the other thing, right? Usually when I record for the last month or so, I've been at my sister's place in Las Vegas, and she's not a content creator, so she doesn't care about having a crazy internet service. And me, I rely on internet because of so much of what I do with content and with cybersecurity in general. And I went from a gigabyte per second, which was back at my place in LA, and now I'm at 100 megabytes per second, which is where I'm recording this whole thing. So this is, as you can see, it's like pulling teeth, as they say. So let's click on refresh, or let me actually just make sure that this thing is completed. I should have just waited for it to be complete before I left the window. We'll wait for that to complete. Once that's been completed, I'm going to come back and I'm going to refresh the logs to make sure that we have it. And there we go. It is completed. So we can now minimize this. This reminds me of like the time when I had my very first computer ever, and it was like just a super slow freaking computer. So when you click on anything, it would just take forever for it to load. So now we have that. Great. Now we can go ahead and click refresh, and we should be able to see some events generated. And hopefully these events will have event ID 13, because if they don't, it's going to take forever for me to find them. So number of events, 15. And let's make sure that we can actually see our event IDs on the screen here. Okay, so no event ID 13s in this list. So what I want to do is I want to go back to my applications and go look at Aurora to see if I actually have the same series of events with the same event IDs. If I do, I'm just going to stay in the Aurora events, the Aurora logs, so we can kind of use those instead of using these ones. Okay, so this does not actually have the same event IDs as the other one, which is an implication that we should actually be inside of the sysmon events. So there's that. At the very least, I found that out. Now I'm going to go back to the sysmon events, and from there we're going to run the next step. So just remember that every single time that you do this, you need to actually be, you need to clear the logs just to make your life a little bit easier. So we are now inside of the sysmon events again, and there we go, we have that. And same thing, so same series of events that we had previously with event ID 11, etc. So now I'm going to clear these events here, and then we're going to go and run the next step. Okay, cool. So now we have this one that has been completed, the third step. So let's go back to our event viewer here and see if we have anything that has event ID 13 associated with it. And then there is one that is specific to event or the execution of the fifth ability. So as of the fifth ability, we'll start paying attention to everything else that's going to take place as well. But we are officially here now. So let's go ahead and refresh our sysmon events and see if we have anything that shows us event ID 13. And boom. Okay, so this is actually the one. Excellent. It's only 3 events, and one of them is the registry value change. So the name of the ability, right? So what is it right here? It says, what is the name of the ability that generated a sysmon event of 13? And that's what we're interested in, the actual name of the ability. This is not the name of the task category or anything else, right? So it's the actual activity itself, which is winlog on HKLM, etc., etc. So I'm going to copy that, and then we're going to take it to our question answer right there. Okay, so I manually typed it because the copy paste was taking way too long, but that's the answer. So we got that, sysmon event ID 13. Excellent. Now we can move on to the execution of the fifth ability. What's the value of the match strings field in zip folder? So I'm going to do this just to kind of save time a little bit because I know we're going for the fifth one. So I'm going to run this one more time to actually execute the fourth one. And then after the fourth one has been done, I'm going to go clear the logs. And then from there, we'll run the fifth one, and we'll be able to find that specific activity or ability, I should say. And then we can move on to the sixth one, and then pretty much we will be done with this, and then we can do the autonomous incident response, and then the case study, and then officially we'll be done. When I tell you, so what you're going to see in the final video is probably not going to be as long as it has, but if I remember correctly, we were like sometime at 1 something. Let's say it wasn't even 2 o'clock that we started it, and right now it is 5:15. So when I tell you that this thing has taken a long time to record, it's mainly because of the fact that my internet service is so freaking slow that these things aren't loading the way that they should. Okay, so there we go. Ability number 4 is officially done as well, and now we can go ahead and look at the event, and we can clear the event and then move on to ability number 5 and get the information that we need. All right, cool. So we have now ran the fifth ability. So zip a folder is the ability. And now we get to minimize this and go look at our logs. I've already cleared the logs after the fourth ability was ran, and we can now check to see what so what's the question here? It says, during the execution of this, what is the value of the match strings field in zip a folder with PowerShell for staging in temp detection? So we are looking for the match strings value inside of this. So I can go ahead, and match strings value implies that we are looking at the Aurora agent. So now I need to go back to the very top. I didn't clear the Aurora agent. Oh my goodness, I should have cleared the Aurora agent. I did not clear the Aurora agent because I didn't think that we would be looking at match strings. So now I gotta probably sift and sort through a good number of events to try to find the most recent one that has to do with match strings. I think it has to do with all of these 99 ones, because the ones that have the warning signs would be the ones that are the suspicious execution from parent process, which is that Firefox exe. So looking at the thing that has the match strings for zip a folder with PowerShell for staging. So that's kind of what we're looking for here. Okay, so here it is. This was one of the more recent events, so thankfully it's not that crazy of a thing. It does say compress archive path, and then there's a bunch of other things. So this whole piece is what I need to pull from it, and compress archive path in command line. I think that's like the full value. I just need this to finish loading in order for me to be able to access that full element right there. So this is actually what we have here: compress archive path, etc., and it goes all the way to the command line portion. So I'm going to try to highlight this now, and then I'm going to try to copy it and then send it to our question, and then we can move on to the last question, and then we can move on to the next section. Okay, so this was actually not the answer that we were looking for. I went to the next event, the very next event, which is the first event ID 99, and the name of it is actually zip a folder with PowerShell for staging. So that's actually the name that you're looking for the general rule, etc. So for this one, once I actually get to the match string portion of it, I am fairly confident that this will be the one that I need to copy and paste. So I'm going to go ahead, move towards that portion of the details, and then from there we'll be able to pull that data that we need. Okay, so after much tedious searching, this is the response. This is it took a long time to go through all of those freaking log items, and I don't know what number it was. There we go. That's the freaking answer. But just to kind of make your life a little bit easier so you could actually see what the command was, this is the command, right? So this is the match strings element, in case you need to find this for yourself. Single quote compress archive space single quote space in command line, etc., etc. So the identical as to what you see on the screen over here is what you should be using for your response, because I honestly would not be able to tell you what event it was that I actually found it in, and I should have cleared the logs at the very beginning and read the question, because the question says match strings field, and this one also talks about Sigma rules. So once you clear the logs, it's much easier to sift and sort through these events, especially when the computer is being as slow as it is right now. So there's the answer for that one. I am now going to clear the logs, and then we're going to run that final 6th step. And then from that 6th step, we're going to move on to the next task. And then after that, we have the actual the practical examination that they gave us for the specific room. So I'm going on, I want to say like an easy 3 hours of recording, I think, that I've done today just for this thing. You're not obviously going to see that because a lot of it was just sitting and waiting. So after that's done, you'll probably end up seeing what happens at the end when you get like the final result of everything, and hopefully it won't be too long of a recording. But for me, in this particular case, this took a sweet amount of time to be able to get this video out. And I hope you actually watch it. And I hope you actually go through these exercises and you get some value from it and you learn a lot and all of that good stuff. Because let me tell you, this was an experience. Okay, so as soon as I'm able to click this run one link thing right here, we'll go ahead and do it. And then there we go. So it actually activated. So it's running that final link. And I have already cleared the freaking logs. I just got scared for a second. I was like, did I clear the logs? I forgot if I cleared the logs or not. I did clear the logs. So now we're just going to wait for this last one to finish. And then from there, we're going to go ahead and review the logs and get that final answer, which is during the execution of the 6th ability, what is the title of the Sigma rule that flagged the usage of the string join, split, etc., etc. So I wonder if I could actually search through all of the log contents for the event that actually has that string, because if I can, that would be very useful. And we can kind of move on quickly. So we are going to minimize this because that ability has finished. And we're going to go back to our Aurora logs. and see which Sigma rule matched it. Okay, so this one doesn't have that many events, which is nice. It's only 10 events, and there's a button right here called Find. So let's see if the Find button will actually allow me to search for a specific string. And we're going to paste that. We're going to do Find Next and see if it shows up. And it highlighted something for me immediately. So that's actually really nice. And that's the event right there. So let me go inside of this event and see if this is the one. The title that we're looking for is Hack Tool Crack Map Exec PowerShell Obfuscation. So just in case, I'm going to copy this name right here. I think that might be it because it literally highlighted the event of interest for me. So hopefully that is it. This is the one. So match strings join yada yada yada. So that was the one. I'm glad I highlighted it and copied it. And there it is. So we got that one, and now we can move on to the next task, the autonomous incident response task. For this specific exercise, we need to log into Caldera as the blue team. So I've already logged out from the red account, and we're just going to log in as the blue account. And I closed the Python server that I had in one of the terminals just to hopefully improve the performance of our virtual machine here. So I'm just going to log into blue, and it's going to be the same thing. Blue admin would be the password. And then we're going to log into it. And then let's read through the instructions here. So evidently, after we log in, the theme is going to turn into blue color because we are now in the blue team and the defender. So we have agents, ability, defenders, and operations, which is still available. So before proceeding, this is what we're going to be talking about: introduction to the response plugin, sources and facts, incident response scenario, and running blue operations and reviewing results. So this is the response plugin. So under the plugins itself, you actually can click response, and this is what you'll see right here. And then in this version that we have, there are currently 37 abilities that we can use and 4 defenders that we can use. The defenders are the counterparts of adversaries. So blue team profiles basically that contain abilities to execute detection and response actions. And we have the incident responder, the elastic hunter, query sysmon, and task hunter. That would be the current defenders that we have. So response plugin abilities. So if we go under, where is this right here? They're under plugin, and I guess the chosen one would be response. And then if we choose the response plugin, these would be the list of the abilities that would be available for that defender profile. They are mapped with the MITRE attack tactics and techniques, and the response plugin abilities are classified by 4 different tactics: the setup, detect, response, and hunt. So abilities that prepare information like baselines that assist others, abilities to determine outliers, abilities that focus on finding suspicious behavior by continuously acquiring information. Abilities under this tactic have the repeatable field configured, meaning they will run and hunt as long as the operation runs. Abilities that act on behalf of the user to initiate actions like killing a process, modifying firewall rules, or deleting a file. And abilities that focus on searching for malicious indicators of compromise via logs or file hashes. So these are the 4 that we have. The defender profiles are currently installed at the blue teamer's disposal. For this task, we're only going to focus on the incident responder profile. And it contains abilities under 3 different tactics: detection, hunt, and response, making it a good example to compare to everything else. And we can navigate to the Defenders tab from the sidebar and use the search functionality to display the abilities connected to Incident Responder, as we have at the top right here. And then we can see all the abilities that are available to it. And enable inbound TCP UDP firewall rule is the one that's been highlighted in this case. So try to hover over these things. Ability, you'll find that there's all, if we hover over find unauthorized processes, which I guess would be, where is that? I don't see it right here. So it says try to hover over the find unauthorized ability. You'll see that it also highlights enable outbound. I see. So if I do, if I try to hover over that, it'll also hover over this thing right here. So this means that these two abilities may unlock or require a value for each other to execute the command successfully. Given these two abilities, you may see that the find unauthorized processes ability unlocks the remote port unauthorized value, while the enabled outbound TCP UDP firewall rule ability requires the same value to execute blocking unauthorized network connections. So if we hover over them, we can see remote port unauthorized are both the values that needs to be done or that are required for these specific abilities to run. So to understand this, we can now hover over the connections of each one, and we can see that find unauthorized processes leads to enable outbound TCP UDP firewall rule. Find atypical open ports leads to kill rogue process. Hunt for known suspicious files leads to delete known suspicious files. Once you execute this profile in the following instructions, you will see that the abilities that require a value do not execute until the prerequisite abilities have gathered the data, the facts, so to speak. So this means this makes sense since the prerequisites abilities under the detection tactic and the abilities that require value are under the response tactic. You cannot automate the response without appropriately detecting activity. So reviewing the abilities now, this will go and focus on checking the values of find unauthorized processes, and we can click on it to view the configuration. We can observe the repeatable field is already checked, which means configuration will continuously run. And we can scroll down the executor commands, and it'll see that on a Windows platform, it uses PowerShell as normal. And then we have the getNet TCP connection remote port command that's running for this. And the command attempts to look for TCP connections with a specific outbound port and returns the process that initiated the network connection. You may see that it uses the remote port unauthorized value for remote port parameter. This ability does not require any prerequisite abilities before its execution, which means it uses a fact that's been pre-configured using the Caldera instance. So, sources and facts. Facts are identifiable pieces of data, may be acquired by agents during the execution of abilities or loaded from the pre-configured settings. Sources are groups of facts. You already have encountered configuring sources while creating an operation, but we only use the basic source previously. So now we're going to talk about the default resource for the default source for the response plugin, which is the response source. So we'll navigate to fact sources, and from the lower part of the sidebar and filter the view to response resources by selecting it from the create resource button. And then you'll see that remote port unauthorized fact is seen in this source and has the following value of 7010, 7011, and 7012. These facts can be configured based on the detection needs, such as adding a new port in remote port unauthorized fact or adding a new search path in the file search directory fact. The image below shows that we consider port 4444 an unauthorized remote port. That's typically the port that's used for Metasploit MSF Venom reverse shells that are created. So don't forget to click the save button to apply the changes, so we can actually go ahead for the remote port unauthorized and just add a new value for 4444 and just make sure that we save it. And the uses of this makes the operation execute the ability 4 times, one for each port, and a sample command would be like this. So getNet TCP connection, remote port 7010, 7011, 7012, and 4444. Incident response scenario. Now that we actually know this, we're going to run this using the incident responder profile. Since we aim to utilize the incident responder profile, we will establish a reverse shell from our victim machine to our attack box instance. Note that in the next terminal snippets, the blue terminal pertains to commands for the victim machine, obviously because it's PowerShell, and the black terminal is for the attack box. First, we set up the netcat listener on the attack box using this command right here. And then next, we're going to use the tool for the netcat executable from the victim machine to actually connect to our reverse shell. Once the reverse shell is established, you'll see that the attack box has now a command shell that we see right here that will be inside of the tools folder on the Windows machine. Before running an operation, we need to deploy a new blue agent in our victim machine. So we navigate to the Agents tab, click Deploy an Agent, and select Sandcat and replace the IP values with the attack box's IP address. If it's on your own computer, if you're using Linux or Darwin, which is Mac OS, you would essentially just put in your specific IP address for your machine. Then we scroll down, make sure that you have the appropriate command line that's been selected. In this case, it's going to be PowerShell. And then we're going to take the very first one, deploy a blue team agent instead of red, and we're going to copy that, and we're going to continue to create the responder profile. So now that, like how we created the red operations, you can create the blue operation by navigating to the operations tab and clicking create operation. And from that, we can do the adversary defender field to incident responder, fact source to response, group to blue, planner to batch. And these would be the things that we would be using. It's very similar to the other operation that we actually selected. So incident responder, fact source would be response, group would be blue, planner would be batch in this case. This would be the only thing because the other one said atomic, and it's going to stay at plain text, and it's going to stay at run immediately, and everything else should be fine. So that is all we have, and then we're going to get, what is it? I think 5 questions that we got to answer. How many instances of the find unauthorized processes ability have failed during the first batch of execution? Upon checking the find unauthorized process ability results, what's the name of the fact that returned a value aside from remote port unauthorized? What is the group value of the new firewall rule created by enable outbound TCP UDP? Aside from enable outbound TCP UDP firewall rule, what is the name of another responsibility that was executed after detecting this suspicious process? And what is the name of the PowerShell commandlet executed by the ability referred to in Q4? So these are our questions. So we're going to start from the very top here. I'm already logged in to it. So the first thing that we got to do is first, what are we going to do? We're going to go and look at the plugin abilities, I believe. Or I don't think I even need to do that because there's nothing that I need to modify based on the plugin abilities for response. The first thing that I need to actually really do is to go ahead and modify the ports. I think, like, as far as running the exercise itself is concerned, we need to modify the ports, because apart from the instructions that they gave us from the very, very top right here, like the only piece that really comes in as far as things that we need to edit would be the things that we need to start creating. So the abilities, for example. So this is the piece right here, the last piece where it says remote port unauthorized. Are the required ones for this? So you will hover over the abilities to understand the connections of each one, and then we can see right here. So all of these things don't require us to do any modifications. The only one that does is when we start doing the reviewing abilities. So when we go to the abilities, we can focus on checking the values of the find unauthorized processes, and you can click on it to view the configuration, which ends up being repeatable, etc. Windows, PowerShell, and then the command that's run over here, etc. So all of those things, again, still don't require any modifications from us. It seems to be that when we actually get to the fact sources element and we're looking at remote port unauthorized, that's the one that we need to add that extra port to it. So let's go inside of our location here, and it says towards the bottom right here is where we can actually see under configuration, we can see the fact sources. So this is the piece that I would click on to be able to look at the various fact sources that are pulled up here. And from here, we should be able to go to select the source and use responder, and then, or response, I should say. And then once we choose that, now we have all of these things, remote port unauthorized. So now I can click on remote port unauthorized and add that new port that we have over here. So we'll just press this plus button, and then it should allow me to do a new value of 4444. And then once I have that, I will go ahead and save it. So just got to make sure that this actually inputs everything excellent. So now I'm going to save it, and that should be good. And it has officially saved. And now we can see 4444 has been added. So that's great. So perfect. Now these are the commands that are running. So none of these things I need to do anything for, because these are just the commands that are going to be running individually, and it's going to check for each individual port. So now the scenario is to create our netcat listener, and then from there to go ahead and run it, the netcat executable from the victim machine, so that we can connect to our netcat listener. And once we do that, it should technically go ahead and launch that operation that detects everything for us. So I think we need to run the netcat listener first. So let me just review these instructions real quick. see if we need to run the operation first or if we need to run the netcat listener first. Okay, so yes, we are first going to do the netcat listener, and we're just going to go over here, and this one is fairly simple, very similar to every other netcat connection that we've ever established. The challenge, and I think like the hard part about this room, where they were like, yeah, this is a hard room, is that it's so slow. So that's the one thing that is kind of the what can I say, the little bit of an issue that I'm having with this whole process, is that it's just so painfully slow to be able to run this. I almost want to completely break everything down and restart everything from scratch, and that might maybe speed things up. So I'm actually going to do that. I'm literally going to break everything down right now, and then I'm going to reconnect everything, meaning I'm going to run all of the instructions from the very beginning to connect our agent to because we need to do that anyways. We need to actually connect our agent for the blue team anyways. We need to actually go ahead and create that new agent and then connect it to the Caldera instance. So I'm just going to break everything down. We're going to terminate everything, break it down, and then we're going to restart everything. And then you'll see it in a flash. You'll literally see it in a snap of a finger, but I will have done all of the work initially to establish the Caldera instance. And then from there, I will come back here and then we'll just recreate the agent for our blue team, our defender agent. So I'm just going to reset up the Caldera instance and then we'll do the blue team agent. All right, so I crashed, I took everything down as far as all the machines, the virtual machines, the attack box, the victim machine, all of those things. I took everything down. This is actually day 2, so I'm doing this on a completely separate day. And it seems to be that the virtual machines are way more responsive and they're much faster. So hopefully this will actually be a little bit easier to navigate as we move on towards the last couple of tasks here. And I have brought myself up to date, or up to the very last element that we had, which is I essentially added this port 4444 on the remote port unauthorized, logged into the blue team of Caldera. And up until this point, everything is exactly as it was before. Now, there's 2 other things that I have to do, which is I need to create that reverse shell so that we can connect netcat from the victim machine to the attack box. And then I need to also actually launch the attack box. And then there's actually a third thing as well. We need to launch an agent on the victim machine for the blue team. So those are the 3 tasks that we have in front of us right now. So I just added this remote port unauthorized, the 4444. So the next thing based on the instructions is for me to establish the netcat listener and connect to that virtual machine, the victim machine that we have. So I'm going to just minimize this right now. This is the terminal that has to do with our Caldera instance. So we'll just put that to the side here. I'm going to open up another one. And in this one, we're going to log into the victim machine via remote desktop. So the RDP connection to the victim machine is going to be the communication here. So let's do this one real quick. And if you remember the command, it's xfreeRDP. So let's do that. And then /v is going to be the IP address for the machine that you are connecting to. And then /u will be the username, which is administrator in our case. And then /p is going to be the password, which is emulation 101. And then exclamation at the end of it. And then it should ask if I want to accept a certificate, because this is a completely new sign on a new day. And then when I say yes, we have our RDP instance. So that's great. So that's working as well. So we'll also put this terminal to the side over here. We're really not going to be messing with any of these terminals because they're basically just running the 2 connections that we have. One of them is the Caldera instance, and the other one is going to be our RDP, our Windows machine. So now that I have this, I'm going to open up PowerShell to just get that ready. And I'm going to open up this terminal here. And inside of the 3rd terminal that we have is where we're going to establish our netcat listener. So we have our reverse shell or our listener available so that we can establish a reverse shell. And essentially what it's going to be is a very basic netcat command with just a few arguments passed to it for, getting the host name for the interface, etc. So really, really basic listener, nothing crazy. If you've done any of the pen testing exercises that we've done together, the junior penetration tester or any of those exercises, you should be pretty familiar with these things right here. So it's going to be, listening on port 4444, and that is the port that we established or we added to our filtration, right, on Caldera. So it's going to be something that should show up, hopefully, in the response element of Caldera. And then we're going to print the first position using awk once we've actually logged in, and the first position essentially for the host name. So when you get host name interface and then you pass that to awk and then you print $1, you're printing essentially the first column, let's say, or the first position for that once the connection has been established. So you're doing host name dash capital I for the interface that you're in, or interactive. I think maybe it's either interactive or interface, but I want to say that it's interface. And then you're just printing that first position once you've established your connection. So we're going to do that. And now it says it's listening on port 4444 on the attack box IP address, which is this port that we have right here. And the instructions tell us to establish the listeners and everything first before we go ahead and create that agent, that blue agent, to launch on the Windows machine. So now that I have this, I can actually go into the Windows machine here, and inside of PowerShell, we're going to go into the tools, and that's where the netcat executable is going to be for us right here. So there it is, ncexe. That's going to be the executable that we're going to use to establish our actual connection to the attack box here. So we will do whoops, let me just clear the screen. It would be /nc.exe. So the dot represents the current directory, / is just whatever it is. So inside of the current directory, we want to reference ncexe. This would be the same as doing this. You could technically do ncexe, and it should do the same exact thing. And then I need to connect to the attack box IP address, which is that 10.135.196, and it's going to be on port 4444. And then we want to execute the command line. Essentially, I want to execute cmd.exe once I've established my connection. So I'm gonna press enter. I see. So maybe I do need to use that /. So the / is probably something that I do have to do. So I thought I could get away with not using it. So maybe it actually does kind of require that we do that. Previously I thought that you could just do that. There you go. Yeah, now it works. I have done this in other instances where I thought that it would actually work, and there we go. Our command line is actually established. Our shell connection is now established using netcat. So we have our tools directory, which is the same directory that is on the Windows machine right here. So you can see that that connection is now all good to go. So that's good. So we've officially accomplished everything that we need to in this reverse shell connection. So now what we need to do is deploy an agent from the blue team and then run the operation. So I'm going to minimize this one because that is the one that has that reverse shell. And if I close that, it's going to essentially close my reverse shell connection. So I need to open up a new PowerShell. And there is the new one. So inside of this PowerShell, very similar to what we did to develop the red agent at the very beginning, we need to first open up Caldera. And then from Caldera, we're going to go and build our blue agent, right? So we're going to click on agents right here. We're going to deploy an agent. And the agent is going to be what did they say? To do the sandcat agent. So it's the first option. And it's going to be for a Windows machine. So all of these things are going to be exactly the same. And then what we need to do is now put the attack box IP address, right? So that's the thing that we need to connect to here. So we'll go ahead and do that. And let me just make sure that it's highlighting. I see. So, okay, let's go and start from the, it's like they're so fine print and they're so connected together. 135.196. So there you go. There's that. The name, for the sake of this, I'm going to use the same exact name that they use, which is Defender. There are no extensions that they've selected, so I'm not going to select an extension. And then down here, it says deploy as a blue team agent instead of red. That's the option that we want to choose. So when you scroll down, there's the first block of text, which is Caldera's default agent written in Golang. And then you scroll down to the next box. It's the deploy as a blue team agent instead of red. This is the series of code that you're interested in. So I'm going to do this highlight, and then I'm going to hold down shift and just press down to select everything that's too far. So let's see if I can go back. Went way too far. So there you go. That seems to be everything that's available for this blue team box right here. So I have all of that. Now I'm going to copy this, and then I'm going to go to my PowerShell instance here, and we're going to press this. We're going to press enter or enter. Let's see if this actually establishes a connection. If it does, we should get like an immediate connection in the background here, and we should see an agent. And there we go. We actually have that agent. So perfect. Okay, cool. So far, so good. So now what we need to do is we need to go ahead and go to our operations, and we're going to create a new operation. And I'm going to create it. And let's make sure that this is actually, okay, very good. And the operation name. And then, of course, we need to click advanced to get all of the extra options. So operation name is going to be incident response number 1. Adversary is going to be the incident responder adversary. So that should be under I. There we go. Incident responder. Fact source is going to be response. And that's what we also want to make sure that we have selected, because that's where the port assignment for 4444 was. The groups are going to be blue. The planner is going to stay batch. And let's see what other options I need to select here. I feel like everything else is pretty much exactly as it should be. So I don't think we're going to customize anything else. We're just going to make sure that it is batch. The selected adversary has repeated abilities, so some planners are unavailable. Okay, that's fine. They just said to do blue and batch. So that's exactly what we're going to do, because I don't want to have any issues running this exercise. So there we go. So it has been started, it seems. So there we go. It's now running. Okay. And I want to say that's it, right? It's running. It's under collection status, all of them. So I guess I'll give it a couple of minutes to see what happens. So what's the question here? The first question asks us how many instances of find unauthorized processes ability have failed during the first batch of execution. Okay, so there we go. Now all of them have actually gone through. So 3 of them failed during the first batch of the execution. 2 of them were successful, and 1 of them is still in a collection status. So the last successful one still doesn't have an output. So I guess I'll kind of give it still a few more minutes before it does that. But for sure we have 3. Oh, there you go. That other one that was in collection also is now in success mode. Oh, there you go. Now we have a bunch of other stuff that also showed up. So I guess there's several batches that are going to be ran from this. Or I think it's going to repeat. No, it's not. It is repeating it. So find unauthorized process is now being repeated again. Kill rogue process is now being repeated, because this is a repeatable instance. So during the first batch, this is the one that we're looking at. Find unauthorized processes times 3 was done. And then the 4th one was actually successful. Then it went through atypical open ports, acquire suspicious files, and then enable output TCP UDP firewall rule. And then it started again, find unauthorized processes, and it kept going through that kill rogue process. So I'm guessing it's going to just keep going, right? It's going to continue doing this because it's a repeatable element here. So in the first batch that it ran, the 3 were failed. So let's see if that's true. That is true. Now, upon checking the find unauthorized processes ability results, what is the name of the fact that returned a value aside from remote port unauthorized? So upon checking the ability results, what's the name of the fact that returned a value aside from remote port unauthorized? So we would go to the one version or the one instance of the find unauthorized processes that actually has an output, and it has remote port unauthorized, and it has host PID unauthorized. So that would be the fact that is other than the other one. There we go. What is the group value of new firewall rule created by enable outbound TCP firewall rule? So what's the group value of the firewall rule. So we're going to go down to enable outbound TCP UDP firewall rule, and we're going to look at the output here. And the group value is Caldera with an I. So it's not Caldera with an E, it's Caldera with an I. Now, aside from enable outbound TCP UDP firewall rule, what is the name of another responsibility that was executed after detecting the suspicious process? So apart from this, so it says acquire suspicious files, find atypical open ports, find unauthorized processes, and then again it didn't find unauthorized processes, and then it went through that. Kill rogue process, that's probably the new one that showed up. Find atypical open ports, acquire suspicious files, find unauthorized processes, find atypical open ports, acquire suspicious files, find unauthorized. So it's basically doing the same series of steps. The only one that is new in this particular case is the kill rogue process piece. That seems to be new. So we're going to run that. Excellent. And what is the name of the PowerShell commandlet that was executed by the ability in Q4? So the kill rogue process. So let's see what the commandlet is. It says stop process. That's the PowerShell commandlet. And it's the ID is 4580 is the ID that was killed. And so that would be the kill rogue or stop process, excuse me. And there we go. Just like that, we have now accomplished all of the questions, and it was so fast because the internet was connected well, or I don't think it's even the internet at this point. I think it was just because I was connected to these virtual machines for such a long time yesterday that it was like, okay, this is, I don't know, they were tired of me. So now I'm gonna stop this because I think we're done with this, and we should be fine. And for the next series of tasks for the case study, we're going back to the red team. We're going to be using the red agent from what I remember. Create a new thread profile. Yeah, we're going to be using the red agent for this one. We need to use the red account to execute the TTPs. So we're going to essentially be running everything that we ran over the emulation, the in through out. We're going to be rerunning everything from the in through out, but now we're just using it for an actual case study, and we're just going to use everything that we learned throughout this room so far. So it should be pretty exciting. So we're just going to scroll all the way down here. We're going to log out of the blue agent, and then we're going to go and log back into the red agent. And then from here, we're going to start from scratch, and I'm just going to close this PowerShell instance because that's irrelevant at this point. And I guess I don't even need this anymore because the reverse shell is also irrelevant at this point. And I can even close this terminal because, well, it already closed my connection to that shell from the Windows machine, so we could just close that terminal as well. So now we are good with this. We are just going to leave our Windows connection, and we're going to leave the Caldera instance up and running. And we're going to go to case study emulating APT41. APT41 is also known as the Double Dragon, and it's a hacking organization that has been active since 2012 and is believed to have alleged ties to the Chinese Ministry of State Security. And the group has been known to engage in cyber espionage and individual financial gain, hence the origin of the moniker Double Dragon. Very, very cool, of course, Double Dragon. The Chinese are really big on dragons in general. Overall, it's just super freaking cool. Purple team exercise is the emulation of APT41. So purple team is a combination of the red team and the blue team together, hence purple. We are tasked to emulate the TTPs of APT41 and known to target similar sectors like the healthcare, telecommunications, and technology. These are the tactics and techniques and their ability names associated with it inside of the red team version of Caldera. So I really hope that this is already available to us and we don't have to modify any of these things, because if we do have to modify them, they don't give us any instructions for it. They essentially just kind of give you the guidelines for what you're supposed to do, and then from there you're just running the test. If I have to modify them, then that would be considered a hard exercise for me, and I would have to go through MITRE and do a bunch of research to try to find out exactly what we need to do to modify these elements. But apart from that, everything else should be fine. The spear phishing attachment element is very similar to what we did in the last exercise. So the macro enabled spear phishing attachment, we would be changing the URL for that, create a process using obfuscated Win32 process, execute a command as a service, PowerShell command, let's schedule a task, create a new user, clear logs, file and directory discovery, and find files. So apart from I think apart from this specific one, the rest of them should be relatively easy to execute. So that's the piece that I'm most curious about. So before I jump into any of this stuff, I'm going to go ahead and review that last task that we had, the one that we did where it's in through out, that whole thing. I'm going to review that to see which ones we actually modified and if any of them fall into this specific list as well. And if they don't, then we're good. And we're basically just kind of going through the thing. But I feel like at the very least, there is going to be something that will need to be modified for sure. The spear phishing attachment, the macro enabled phishing attachment, that is for sure something that we need to modify because we don't have internet access, and we need to change the URL for this to the URL that would be connected to our Python server. So if you remember that piece, we're going to redo that piece to make sure that we have that Python server, and then the phishing attachment will be launched to that. And then there is nothing that we have to do for zipping a folder and compressing any of that stuff. So that should be fine. And we don't need to create a custom ability either, I don't think, because exfiltrating hex encoded data chunks is also not available here either. So the only thing that we have to modify, from what I understand, is going to be just this piece right here. So I'm literally comparing the two against I have a secondary monitor, so I'm opening, I have the earlier task, the in through out portion. It's already open in my second monitor, and I'm looking at it, and from this, I can pretty much tell that there's nothing else that we need to modify with the exception of this very first one, the spear phishing attachment. So what I'm going to do is first I'm going to create my agent. So that's the first piece that we need to do, is we need to create that agent so that we can establish that red team connection back with our Windows machine. And then once we have that agent running, then I'll go ahead and run the second portion of exercises. So as a review, right? So we need to open up Caldera here, and we need to go ahead and find the agent or create the agent that we want to do. So deploying the agent would again just be over here inside of the agents tab. We're going to deploy an agent. The agent that we want to choose in this case is Manx, which is the reverse shell. We're going to click on Windows, and then this is what is going to be the general information that we have to update. So first I need to assign the IP address of my attack box. And I'm just going to see if I can copy and paste this because I have to do it multiple times. So I'll do copy there, and we'll come here and we'll paste that there, and then we'll come here and we'll paste that there. And then for the hell of the exercise, I'm just going to turn the agent's implant name into Chrome. Literally, I'm going to duplicate everything as it was the last time. And so now we should actually have exactly the same series of code as we had before. So we will now go through this. Boom, 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 and it should be highlighting everything. Perfect. So we'll now copy this, and we're going to go into the Windows instance, which is what's over here, and we're going to open up PowerShell, and we're gonna paste that, press enter, and we should have the agent. I saw the agent pop up, so perfect. So now we have the agent. It's been popped up. So now we have our right agent connected. So that's it. That's the very basics of what we need to do right here. So the next thing that we need to do now is we need to actually create our profile for the adversary. And for the adversary profile, essentially what we're going to be doing is creating it from scratch and then just adding the elements to it that we would need to add, right? So I'm going to do new profile. The new profile is going to be Twin Dragon, and the profile description is going to be APT41, right? Is that what it was? It's APT41. APT41, tactics, techniques, and procedures. That's it. So that's the name of my profile, is Twin Dragon, APT41. Now, what I have to do is I have to start adding abilities to this thing. And it's basically going to be this list of abilities. And one of them, which is the spear phishing one, that's the one that's going to be modified to be able to download from my Python server. So that element is going to be exactly how we did before. So the first thing that I'm going to do is I'm going to first create my Python server, essentially just launch it from the location that has the phishing download. So where's the phishing download? It's in the Caldera HTTP server portion. So we are going to minimize this temporarily, and we're going to go and put this to the side real quick and open up a new terminal. Inside of the new terminal, we are going into the location that has the HTTP server, which is this place, and inside of this should be the phishing attachment. Perfect. So now while we are here, we're going to launch the Python server so that we can retrieve the data that we need from this location while we modify that other piece. So HTTP server on port 8080, and we have it now available. So perfect. So that's basically all you need to do in order for this first element to work properly. You need to create that HTTP server so that when you want to download something, the phishing attachment, essentially when you want to download that phishing attachment, that's the piece that's most important. So when we go to attach that here now, right? So it's the exfiltrating, or no, I'm sorry, download macro enabled phishing attachment is the first one, right? So let me, the first one is download macro enabled phishing attachment. That's the first ability. So I'm going to go here and I'm going to just search for it, right? So download macro enabled, macro enabled phishing attachment. There you go. So this is the first one. I click on this and it's going to load it, right? And it has everything here. The piece that I'm really interested in, based on the instructions that they had, was, first of all, you want to make sure that, let's see, there's a few things that they told us to make sure that we check off. And I think it's the, make sure that the delete element of it is checked off and all of those things. So let me just pull up those instructions real quick. So actually, no, we don't need to check off any of these things. The only thing that I need to modify is to modify the URL here to be the URL of my attack box pointing to the phishing attachment. So that's the big piece that needs to be modified, and it's going to be an HTTP, and then it's going to be the 1010, what's the URL of the attack box? 135. 196. Okay, so that's the first piece that you need to modify. And then the second thing that I need to take off is this whole piece right here, because this ends up establishing an encrypted connection, and that's the big piece that I need to remove. Apart from that, this is it. This is the whole argument or the command that we need to add for the phishing attachment thing to work. And then from here, that's basically it. You're done with modifying this. So we added the phishing attachment. I didn't change anything up here, and then scroll down here, and I just modified the command to read that it's downloading from my 10.10.135.196, which is the location of my Python server, right? So the Python server is serving on that location, and then if anybody tries to download anything from it, it's going to be downloading that phishing attachment. And we reviewed this already in the first portion, when we, not the first portion, but the portion where it's timestamped in through out. So if you go through that timestamp, I do this a little bit more in detail. I'm kind of like breezing through this right now, but basically the same exact thing. So this is done. So now we're going to do save and add, and now we have that added over here, and it worked perfectly. So now I need to go through the rest of the TTPs for the case study APT41. And add each one of those individually. So after the macro enabled attachment, the next TTP is called create a process using obfuscated, etc., etc. So I'm just going to type these and I'm going to add them, and then I'll review after the fact with you, okay? Okay, so here's our full list of abilities that we've added. The first one you saw me add and we modified it together. The second one, according to the lineup of these things, right? So create a process using obfuscated Win32, execute a command as a service, PowerShell commandlet, schedule task, create a new user in command prompt. All of these things were very, very easy to navigate. And then you can always confirm based on the IDs that they have that they are indeed what they are supposed to be. So when I click on any of them, we can actually see that the ID is T1047, and we go here T1047. The next one would be the command piece right here, execute a command as a service, and it's T156902, T156902, right? So all of those were good. The only one that kind of was a little bit confusing was the clear logs using webUtil. And so when I went to search for it, it didn't say clear logs using webUtil. It just said clear logs, and that's the name of it, right? And then so the thing that you need to confirm is this piece right here, the 1070.001, which is that element that, and in the command it says webUtil. So if I come here, it actually says 1070.001, and then it's using webUtil. So that's the piece that is of most importance to us, right? So, and then apart from that, everything else was pretty straightforward. The names were matching it identically, and then we have ended up with 8 items here, and we should have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 items over here as well, and that's pretty much it. So we can go over here and we can save the profile, and now the profile is ready to go, and we can go and start running the operation. Now, as the operation is running, the few things that they said that we need to have is you need to use the red account again, and in addition ensure that the HTTP listener, which is the Python server that we created on port 8080, is also still running, and that is still running. Operation guidelines needs to be all modified. Oh, you know what? This is what I did not do right here, which is going to definitely give me an issue. So that's the piece that I forgot to add for this, and I apologize for that. So downloading the macro-enabled phishing attachment, this needs to actually be colon 8080. Otherwise, that will not work. So hopefully you didn't just skip through all of this entire instructions over here, and you were able to get that piece modified and adjusted as well. So apart from that, that's pretty much everything else that we were supposed to do. And now we have it ready to go. So the guidelines are to create a new thread profile, selecting all of these things, which we just did. Establish a connection to the target machine via an agent, which we also just did. Start emulating the thread profile and observe the execution of each technique, and then document and review the results, and then answer the questions below from this task. Caldera operations page may show that some abilities fail to execute. Review the execution via the logs generated by each ability. So that's the other piece that we need to also do, is that we're going to, I guess we're going to run it one at a time to be able to review the logs that were generated by each one of these abilities. So if you remember, there's a way that we can actually do that. Instead of running it automatically, we would just run it one piece at a time. So now we're going to go to operations here, and then inside of operations, we're going to create an operation, and we will name it Twin Dragon 1. And then the adversary profile is going to be the Twin Dragon profile that we just created, which is right there. And fact source will be basic. Under advanced, I need to do a few things. Number 1 is going to be red, is the group that I want to run against. And number 2 is going to be pause on start, so that we can do one step at a time, so that we can actually analyze the logs piece by piece. So before I click, I technically can click start because it would technically pause on start and it wouldn't run anything for me. But in order to make life a little bit easier, what I'm going to do is I'm going to first go ahead and clear my logs for the Windows logs. Let's see if anything is referring to the match string or any of those things, because if it is, then we need to go to the Aurora agent. So how many times did the find files ability execute? What command is used by the find file and directory discovery PowerShell during the execution? What is the name of the Sigma rule that flagged the execution of the clear logs? Aside from the PowerShell detection, what is the name of the Sigma rule that flagged the execution of that? Aside from the PS1, what's the name of the file created by the execution of PowerShell commandlet? Target file name value, and what is the name of the service created by executed command as a service, what is the match string value of the sigma rule. So it seems to be that most of this stuff is going to be from the Aurora logs, which I'm very glad I checked, because that would be a pain in the behind. So we're going to go to Windows logs, we're going to click on application, and we're going to open up the application logs. The application logs is where the Aurora agent is going to be stored. And we need to just organize this a little bit and then make sure that there we go, Aurora agent over here, timestamp is available, all of that stuff is good, and event IDs are also associated and categories also associated. Although the category, sometimes it is helpful, like sometimes it gives you a little bit of information, but in most other times, like logging, recovery, things like that. But if we're dealing with Aurora, usually there's no task category that's associated with it. So let's see if we can add or remove any columns that might be actually useful to us. So I'm going to try to see what I can add or remove that would be useful to our exercise here. Yeah, really, unfortunately, nothing is available that would be of note that's specific to Aurora anyways. So the big thing that we can do is we can go ahead through these things and we can actually filter the log that it only shows us everything from the Aurora agent. At least that will be a little bit easier to navigate. So I'm going to just scroll down and pick Aurora agent, and there's two versions of it where it's like the lowercase Aurora agent and the uppercase Aurora agent. So I'm just going to choose both of those, and then I'm going to go click OK, and everything will be modified here. And we have 293 events, and then we're going to now clear the log. And once the log has been cleared, we can go ahead and start. So the thing that is good to know is that when you clear a log, that becomes one of the first alerts on Aurora. So we're going to ignore that. And then from there, we're just going to run forward to the operations element. And for whatever reason, it says click on the button on the right to add this. I created the operation, so I don't know why my operation is not here. So let's see here. Oh, there we go. Okay. All right. Run link 1. The first one is complete. So that was the downloading of the phishing attachment, and it did connect to our server, and it was able to download the phishing attachment, and it's been completed. So aside from the PS1 file, what's the name of the file created by the execution of download macro-enabled phishing attachment? Provide the target file name value. So aside from that, what's the name of the thing that's been attached? So let's look at the command here itself. And the out file would be the phishing attachment XLSM. So I guess we're not looking at anything here because the output is empty, which is always odd to me. So we now do have new events inside of this. So let's go ahead and refresh this and see what we can find. So there are 15 events that have been associated with this. The very first one is event logs that have been cleared. The next one would be potentially suspicious extension. Then we have suspicious electron application child process, PowerShell parent process, use of web request commands and commandlets, change PowerShell policies, invoke web request, which is the download probably most likely, and PowerShell web download. So let's see, PowerShell web download, target file name potentially might be interesting here if we actually do have it. Okay, so it's really this, and this was actually not inside of the Aurora log. It was inside of the sysmon log, which is for the Windows event viewer. So, you know, you go through this whole piece right here. If you remember, we went through application service logs, Microsoft, then Windows, and then you just scroll all the way down to find sysmon, and then you go inside of the sysmon operational logs. And then I cleared the sysmon operational logs and ran the whole thing. And this is actually running without my permission because it's supposed to be doing everything piece by piece. So it's not doing it. I stopped it and I reran it and I cleared the logs because I wanted to find that specific target file name. And this is the one that they're looking for. So that would be the actual answer that we're looking for here. But I need to create a new operation and I'll call it Twin Dragon 2. And we'll run that again because I thought that it was going to run on my my individual connection, and it's now doing all of these things in the background, and it's not supposed to be doing that. It's supposed to be doing step by step. So that's my bad. So it'll be Twin Dragon 2, which we're going to run again, and we're going to go through this whole thing one more time to just make sure that everything is all good, and we want it to be done piece by piece. So we're going to do pause on start. So that's going to be the element that we're going to do, and I will not make the same mistake again. So what I'm going to do is I'm going to clear all of the event logs, okay? And then I'm going to also clear all of the sysmon. So let me see if there's a way that I can actually like star this so I don't have to scroll back and forth to be able to find these things. Because it would be very, very useful if we could just kind of, no, I guess there's no way that I can make it a favorite or something like that. But that would have been very, very useful if I could do that. So we're going to clear all of the application logs. We're also going to clear all of the sysmon logs as you just saw me do. And then we'll start fresh again, and we'll go past that first step, which is this piece right here. So once the first step is completed, it says what's the match string value of the Sigma rule that flagged the execution of create a process using obfuscated event 32. So I'm going to run it again, and then it's going to run that first step. So twin dragon 2, there we go. It should be starting from, there we go. So run link 1, and it's going to run everything. And then in the background, we'll see that it's going to re-download that phishing attachment one more time. So this was the first one. This was the second one that I ran after I went to the Windows event log. Now I should be downloading it again the third time. And then that'll be the next run of this. And then this is going to run. And I'm going to go ahead and clear the logs again, because after this is completed, the next step in our lineup of tactics is the create a process using obfuscated. So this has been completed, so we're all good. So we're going to refresh the log. We're going to get all of the sysmon events. We're going to clear the sysmon events. These are the Aurora events. And then we're going to go down to sysmon, and then we're going to clear the sysmon events so that we can make sure that no events are here to make it a little bit easier. Okay, so now that we have this, we are going to, let me go back to Aurora, because the question is asking for the match string value, and that's something that is native to Aurora. So when we go to Aurora, we'll see that, we had a couple of events. So event logs that were cleared, So these are all important notes for Aurora. So we're going to clear this again to just make sure that nothing is there. And then we're going to go ahead and run the next step, which is the step of the create a process using obfuscated Win32 process. So now that's going to run. And then once that is finished, we're going to go review the logs. Okay, so this one came back failed. The creating of the obfuscated has come back failed. So we're going to refresh this, and we have several events here. The first one is going to be event log has been cleared, potentially suspicious execution from a parent process. And so what's the question? It says, what's the value of the Sigma rule that flagged the execution of a create a process? So the Sigma rule, potentially suspicious execution from parent process in public folder, could that be the name? The match string value of this. So let's go and review it. Although I don't know, maybe it is. So this one is suspicious electron application child process, suspicious PowerShell parent process, change PowerShell policy, and spawned a process. So let's look at this one, the one that spawned a process, and let's see what the match string value on this one is. This is the one, I think. So this is actually the most recent event. So this was the last event, technically, the most recent one. It's the top event when we look at all of these things. It's this one that says WMI PRVSE spawned a process. I want to say that that's the actual value that they're looking for match string, and it is. Okay, great. What's the name of the service that was created by execute a command as a service? So that is going to be the one next in line, right? So execute a command as a service. So we are now going to, again, clear these logs. This is kind of like the process here, just to make it easy for us to find the information that we need. So we cleared those logs, and we're going to come down and we're going to clear the sysmon operational logs as well. And now we're going to have two events inside of the Aurora agent for clearing logs. So we're going to make sure that we ignore those first two events, and then we're going to run this now. So this should run the very next one, which is going to be execute a command as a service. And it says, what is the name of the service that was created by execute a command as a service. So this is what we have here. And so let's look at the command here. It says create art service. I believe that's actually just the name of the service because that's what it's trying to create. So that's the name of the service. Let's run that and see if that's actually the answer. I feel like that should be it. Yeah, art services. That one was literally right in the command. We don't even need to analyze logs for that one. So that's a little bit easier. But it is also failed. So it is what it is. Aside from the PS1 file, what is the name of the file created by the execution of PowerShell commandlet scheduled task, which is going to be the very next one? So now we can go back here, and again, I'm gonna just refresh and clear these logs because these are the ones for that previous one, execute command as a service. I'm gonna clear these logs right here, and then we're gonna go all the way to the top and clear the application logs for Aurora as well to make sure that we have a fresh set of stuff. Okay, great. So now we're gonna run this next one, and this one also came through as a failed execution. So the question again is asking, aside from the PS1 file, what's the name of the file that was created by this? Provide the target file name value. Target file name value is not going to be inside of Aurora. It's going to be inside of the sysmon log. So the sysmon log element, let's go back down here. Under operational events, we have 3, and it says file created. So we have 2 files that were created. There is the target file name, which is atomic task. And then there's another target file name for the PS1 file, which is what you see right here. So they're saying aside from this one, what is the name of the file name, which is that atomic task piece that we see right here. So atomic task would be an answer. So, we need the actual full value here, which is this whole piece right here. So we're going to copy that, and then we're going to paste that here, and that would be the answer. Aside from the PowerShell detections, what is the name of the Sigma rule that flagged the execution of create a new user in a command prompt? So now we're going to clear this log, and then we're going to clear the Aurora log as well, and we're looking for the Sigma rule that was flagged. So our Sigma rules are associated with Aurora. So we're going to clear these. Oh, I've cleared the filter, and I am not supposed to clear the filter. I'm supposed to clear the log itself. So I need to add the filter one more time, and then we're going to clear the actual log. So there's the filter for Aurora, and then now we're going to clear the log. There we go. So clearing the log, and now we're going to run the next step of this, which is going to be the create a new user, right? So PowerShell commandlet schedule task. Now it says create a new user in command prompt. So let's see if this one actually is successful. Everything so far has been failed. So let's see what comes up next. Okay, so this one failed too. Very good. So far it seems to be a pretty bad exercise, or not a, I guess not a bad exercise, but the security seems to be a good one here. So what's the rule, right? So that's the question here. It says, what's the name of the Sigma rule? Aside from the PowerShell detections, what's the name of the Sigma rule that flagged the execution of a create a new user? So we're going to look at everything that has to do with PowerShell detection. So the very first one right here should be event log cleared, potentially suspicious parent process and folder. Let's zoom in so you can kind of see it. Suspicious Electron application, child process, PowerShell parent process, PowerShell new user created via net exe. So that is probably the name of the thing that we're talking about here. Excellent. Cool. What is the name of the Sigma rule that flagged the execution of clear logs? And clear logs is actually something that's separate from me manually clearing logs. So it's the next step basically that we have right after this, right? Create a new user, and then we have clear logs. So we are gonna clear the logs, and this is going to be separate from the actual execution of the clear logs ability. So I will now run the ability, and that's going to be the clear logs ability. Now, this may or may not be successful either, so we'll see how that goes. And yeah, based on that, we'll go ahead and look at our Sigma Aurora events and see what the rule was that detected the clear logs. Okay, so this one was successful. So we actually achieved success with that. That's nice. Let's refresh this link, and we have 12 events here. So the very first one, again, is me clearing the log. So just keep that in mind. The next one is potentially suspicious execution, suspicious electron, suspicious PowerShell parent process, change PowerShell policy, important Windows event log cleared. That seems to be the one. So Windows event log is web util. So right, Windows event log. So let's go. Oh, that's not it. So what's the Sigma rule that flagged the execution of the clear logs? I thought that was it. So see details. So maybe that's not it. So let's go to the next one. Suspicious electron child application, PowerShell parent process, change PowerShell policies, potentially suspicious execution from parent and folder. And what else do we got here? Suspicious event log clearing or configuration change activity. That could be another one. So let's try that one. That might be the one that they're looking for. Let's make sure that we're at the beginning of our, and that's not it again. So suspicious event log clearing or configuration. So if that's not it, then what is it? Okay, so this is actually correct. So we have found the appropriate rule, and everything that we've done is correct. So based on a little bit of research that I did to just make sure that we did the right thing and there was nothing incorrect about the process, it is actually right. So it is, it's not, the wording, I guess, has changed ever since we did this. So it's suspicious event log clear or configuration change. That's basically it, which is more or less pretty much same thing that we have here, right? So suspicious event log clear or configuration change activity. So the rule is, or the name of the rule seems to have changed for whatever reason. If we go inside of the rule, the name of the rule title, suspicious event log clearing or configuration change activity, detecting the clearing or configuration of a log using web util, PowerShell, and WMIC. This technique, da 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 da. So when you go through this thing, it's exactly the same as what should be detected. It has been modified as of 7/13/2023, which I think is kind of implying that the rule name potentially was changed in that process. But we detected it correctly. So everything that we did was correct up until this point. If you're running along with the exercise with me, and for whatever reason, you weren't able to find the answer to this question, as long as you did what I did, you have done everything correctly. It's just that the rule itself was updated, and as of the creation of this room, right, 644 days ago, technically from where I'm running this right now, 644 days ago, was definitely... So when they created this room, it was before July 13 of 2023, because right now I am in April 1st of 2025. So when we're looking at 600 something days ago, we're definitely looking older than that. So just to kind of give you a little perspective here, I think you're okay as long as you ran the exercise the way that we were supposed to run the exercise. And then the rest of the information, you don't have to, you just got to make sure that the formatting of the question or the formatting of the answer is right, because that's what it was called. The Sigma rule itself was called that at the time that this room was created. And ever since then, the rule has been updated. So just keep that in mind. What command is used by file and directory discovery for PowerShell during the execution, which is now going to be the next thing. So after clear logs, it's going to be this thing. So we are now again going to go clear our logs here. And then we will also, it's asking for, let's see, what command is used by a file and directory discovery during the execution. So we're actually looking for the command itself, which I don't even need to look at the logs at this point, because I need to look at the command that's being ran. So we will now run the next link. And then as soon as that loads, I can just look at the command. So file and discovery, we can look at the command. And that's definitely not it. So it's not the file and discovery command, because that's the one that showed me the clear logs. So I need this piece right here for file and discovery for PowerShell. So we need this command to upload. There we go. So ls recurse da 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 da. I believe that should be the command that we're looking for here. So let's go here and run that. Excellent. And how many times did the find files ability execute? So that's the final piece that we need to look at here. And of course, that came back failed as well. And then we just need this one final answer. So we're going to, I'm just going to run the rest of it because it would be the find files ability that we need to be concerned with. I will go ahead and clear the log one last time just in case it would be relevant to what we're potentially looking for. But I think we just need to see how many times the find files ability executes. So I'm going to clear all of my logs just in case. But what I'm going to do, because that is indeed the last step that we have here, the find files is the last step that we have. So I'm just going to click on run. Instead of doing click run one link, I'm just going to click on run. And then from here, it should just run the rest of its abilities as many times as necessary. So we'll see how many times this find files ability runs. Okay, so I only have 3 executions of this, and after this it didn't even try to make any more attempts. It does still say that it's running, but just based on the experience that I've had with this thing, usually if it is running, at the very least you'll see something that's in collection mode with the orange circle, and we don't have that here. So 3 attempts would be the last version of this. So I'm going to make a try here. I'm going to try to see if it is actually 3. And if it is, we are officially done with this exercise. So let's see. And we are done with the exercise. So congratulations on completing the Caldera room with me. So I'll tell you this much. This was supposed to be a difficulty rating, and I feel like I have come a long way personally. If you've been with me throughout this journey of cybersecurity and going through all of the various rooms in TryHackMe, especially towards the beginning, because at the beginning I did not know what the hell I was doing, and I was reading every piece of instruction and going back and forth, and I'm like, man, like I feel bad. Like I felt insecure about my skill set, and going through a room that has been flagged as hard, as especially like I've gone through some rooms that were flagged as like intermediate, and I had a harder time. So I don't know, there was just something about this where I'm like, man, this was not that hard. Like I just went through all the instructions that they provided, and we were able to accomplish everything step by step, with the exception of the speed of the connection to the virtual machines, and that one last question where the formatting of the title had changed ever since they created this room, and the rule itself has changed, but everything else was done perfectly fine. I mean, I genuinely feel very confident after going through this exercise, and I hope you do too. I hope as you went through this with me, you had a chance to see your own development in this room. I know that there are a handful of students that I'm in communication with regularly because we DM back and forth for the Hackaholics Anonymous Discord, and like we actually really get a chance to communicate about these things. And I know for a fact that there are several people that go through all of these rooms, and I know their skills have also developed as the beginning of this channel, which was January of 2024 is when I started this channel. And ever since then, I've gone through a massive learning curve. And I know that other people have also gone through that learning curve. It's just, this is like a long-winded version of saying I'm so happy that this was accomplished. I was able to complete this room, even though it's flagged as a hard room. And it was a very pleasant experience because Caldera is a very useful tool. The ability to connect a server to an agent is a really, really key skill. And we did that multiple times here. We did it 3 times. We did twice for the pen testing element of it, the red team element of it, and then we did once for the incident responder red team, the blue team element of it. So the ability to connect a server to an agent is a very big skill in cybersecurity, because that's one of the big things that you have to do when you configure endpoints, the endpoint detection and response piece. That's one of the big things that you have to do, is to connect the endpoint, which is the computer, to the main server that is going to be capturing all of the data from that endpoint. So we did that, and that was fairly easy to do. Caldera makes it very easy to connect endpoints to the server. And again, this was just really, really excellent. I cannot sing enough praises about the instructions of the room creator, the person that actually did this. Very, very powerful set of instructions. It was very, very easy to follow. I enjoyed it immensely. And this is one of those experiences. So whoever this person is, this R33ZY, whoever this person is, very, very happy that this person created this room and they did this for us. So I'm super excited about it. And I genuinely hope that you actually got some value out of it as well. If you did get value out of this video and from this room, I would highly encourage you to like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel about SOC Level 2, about the CompTIA Pentest Plus playlist that has already been started. We have videos that are going to be coming out weekly. And of course, everything else that's going to be coming out from this channel, because I personally am not planning on stopping this. And it's a very enjoyable process for me to actually learn these skills and go through this, and most importantly, share these skills with you. And I genuinely hope that you're having fun through this process as well. So if you have any comments or any questions about what we went through today, make sure you drop them in the comment section below. This was a little bit more involved of a room, so there were some kind of nuances that if you don't get the nuances correctly, I would presume that you're going to have a hard time getting the responses and getting the feedback from the systems that you are working with. So if you have any questions or comments, drop it in the comment section below. And of course, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. If you're serious about your CySec training and want access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content, and the Agent, Guardian, and Master levels get exclusive content, exclusive downloads, monthly Python automations, live streams with me every month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section. And that is it for today. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. And I will see you in the next video later.